morning to everyone and welcome to the audience here at our facilities in Pozo Izquierdo. I'm Gonzalo Piernavieja. I'm the Technical Director of the Canary Islands Institute of Technology. And I welcome also the audience that is visiting us via streaming. First of all, I would like to thank you for coming and for joining the event also online. And I would like also to thank Melissa, Miklos, who is with me, and FEDAREN as a whole. There are representatives of FEDAREN also here, Savas Vlachos, our friend, for allowing this to happen and to organize this webinar and this workshop in this very exciting times when everyone is talking about energy. So regarding us, I will be very brief. Regarding ITC, we are the technology center of the regional government of the Canary Islands. We are working in many fields, not only renewable energies, which is our biggest department, but we are also working in fields that are very important for islands, like water technologies, and for the Canary Islands, microalgae biotechnology, machining, 3D printing, computing, so lots of things in emerging fields. We are 220 people, and as I said, we have a quite big renewable energies department with 40 people, whose head is Salvador Suarez. He will be together with you. And we have also Santiago Diaz here, belonging to Salvador's department. They are both in charge of our hydrogen activities, and we are very pleased that you are here because this place is home of the first hydrogen activities in the Canary Islands ever. We started our activities on hydrogen technologies 20 years ago with desktop studies, with feasibility studies and so on. But we jumped into technological installations almost 16 years ago with 2 systems. I think you will, Salvador and Santiago will describe them a little bit more. Small systems. So we are familiar with hydrogen technologies. Now we are dismantling these facilities because we are updating and upgrading them with a big project, this BIOGREENFINERY project that will be also presented here, where we are also thinking about new fuels and synthesizing new fuels using hydrogen. So we are very happy to have you here, and we hope that you have that you enjoy the time. And I think it's a good opportunity also to share experiences and to make a overall update of what's going on. Hydrogen is crucial for the Canary Islands. We are also not only developing and testing technology here, but we are also advising our local administrations in all these things, and we have particularly tackled hydrogen in the recently elaborated energy transition plan of the Canary Islands. We finished this work last year. We presented, this is a job for the government, of course, it's a plan of the government. We are, as a consultants to the government, responsible for the elaboration. And there is a specific strategy devoted to green hydrogen. We think green hydrogen in the Canary Islands will play an important role, particularly in the transport sector, in the heavy transport sector, and also in the elaboration of new fuels for the internal maritime and air transport. So these strategies are not yet in English, but I think we were discussing this, Santiago, before. It's a big work that we have done with all calculations of what amounts of hydrogen are needed to fully decarbonize our economy by 2040. So the difference between the European targets and the Canary target is that our government wants us to decarbonize 10 years in advance. So It's a hard work in front of us, and hydrogen will play a crucial role. So once again, thank you for coming, thank you for joining online, and thank you, Melissa and Fedaren, for giving us the possibility to share this experience together with us. Thank you.
And thank you very much, Gonzalo. Just a few words from my side. So my name is Melissa Miklos. I'm Communication Officer at Federen. Federen is the European Federation of Energy Agencies and Regions. We have more than 80 members in 25 European countries. And at Federen, we very much believe that European islands can be pioneers of sustainable and innovative solutions and show the way basically for territories, not only other islands, but also other regions in Europe to see what we can do and to decarbonize faster. And I mean, you heard Gonzalo, this is very much what is happening here in the Canary Islands. And this is why I wanted to organize something here with them. And I know it's a challenging period for all of us. They're very busy, but I'm glad we got this opportunity to get together and share experience on a very hot topic, green hydrogen. They were in advance, but now is really a time that green hydrogen is trending, let's say. There is another reason why I'm here is because Federen is involved in the Green Island project, another very ambitious project on green hydrogen, which started 2 years ago, happening on the island of Mallorca. You will hear about it a lot today. And basically today the goal is to get together between ITC's experience and Green Island experts, compare the experience and see what we can do together to go even further and spread the knowledge. So this is also the goal of Federen. So thank you for being here, online or on site, and yeah, let's learn and share. Thank you.
So now we begin immediately with the presentations, and so the first speaker I think is Santiago or Salvador. Is this your speaker?
No, I will be sharing the session, the first part of the coffee break.
Okay, so that you come here, Salvador, and
No, you can stay.
we gain a little bit of time.
You can stay here.
I will stay here.
This is the program we have. And the first speaker, yes, it will be our colleague Santiago Diaz from the Renewable Energy Department from ITC. Santiago is currently coordinating all our activity, not only on energy storage and energy and hydrogen, of course, but also on energy planning. He's also been coordinating activities outside the Canary Islands. Recently, the planning for renewables and energy efficiency in the islands of Galapagos in Ecuador, and currently we have a contract of the French cooperation on 2 islands in Yucatan, 2 Mexican islands, Cozumel and Holbox. Also, the work is being coordinated by Santiago. It's dealing with energy planning on those 2 islands. Santiago is an industrial engineer with a PhD also in industrial engineering. And he has his expertise has been he has been focusing on different issues from weather forecasting through different computer modeling, mathematical modeling, doing with climate modeling, and also energy planning. And he has also coordinated the work Gonzalo just mentioned about the roadmap, the Canary Island roadmap for hydrogen. So Santiago, please, the floor is yours.
Thank you very much. I don't know if... second. Well, now. Perfect. Thank you very much, everybody, for coming to the Canary Island Institute of Technology. My name is Santiago. I work in the Canary Island Institute of Technology in the Department of Renewable Energies. And in this first presentation, our idea is share with you which is the energy planning for the Canary Island, specifically for the case of the green hydrogen, okay? So first of all, we are going to do a little introduction to the situation of the Canary Island for those that don't know our energy systems. And after that, we are going to speak about this objective that we have, for 2030 and also for the total decarbonization before 2040. So, first of all, the first topic that is important is our condition as an energy system. We are insular energy system, as you know. In this case, we are not interconnected with the mainland. It's the only energy system that is not connected to the mainland in Spain. So that is something really important at the end, because you have to integrate this kind of technologies that require a lot of energy in systems that is not maybe the best places to do that in the framework of the electrical system. But it's really important to integrate hydrogen for the reasons that we are going to explain now. The situation in the Canary Island is different from the electrical sector and the transport sector. Okay, in the electric sector, nowadays we have a low demand coverage with renewable energies of around 22%. We have a total low demand of around 9,000 gigawatts hour per year in a normal year. I mean, in 2020, as you know, we have the pandemic and the consumption was a little bit lower, okay? But you could see in this slide that in general, we have increased our production, well, the quantity of energy that we produce with renewable energies, more or less a 40% in 6 years. And that is nice, but it's not enough, because we have to decarbonize before 2040, as we mentioned in the introduction. So this is in the electrical sector, we are advancing, but in the mobility, in the transport sector, the situation is a little bit worse, because nowadays all our transport sector require the use of fuels, okay, and we have to change that, okay. And maybe it's one of the opportunities that we have with the hydrogen. It's a technology that is expensive, as you know, but it's an opportunity to decarbonize not only the transport sector, the road transport sector, but also the marine and the air transport sector. And that is something that is a good approach that we have to explore. So this is more or less the general idea. Here in this slide, you could see more or less the general numbers that we have. Here you have the low demand. It's around, this is for 2020, the last official information that we have at the end of 2020. The total power capacity that we have installed until this year was 680 megawatts, but in the last year we have increased more or less in 160 megawatts more for different wind farms that have been installed. Now we have around 570 megawatts. Also in the photovoltaic power, we are near 205 megawatts, okay? And also we have increased the power in self-consumption, We are in near 60 megawatts in only 1 year. We have increased around 160 megawatts, as I mentioned before. We have to keep this increment in the power capacity with renewable energies until 2030 if we want to reach the objective that we have for this year. So in this framework is in which the government of Canary Island have been working, okay, over the last 2 years, more or less. And they define first of all a set of energy strategies. These energy strategies give us the potential of the different technologies that we could have in the Canary Island. And after that was defined the energy planning, that is the one that should define the objective to decarbonize the Canary Island before 2040, okay? But this is like the PNIEC. I mean, we need to, the objective that we have in this document is until 2030, sorry. So the green hydrogen strategy is one of the key elements, as I mentioned before, for the reasons that I mentioned, mainly for the transport sector, but also for energy storage in situations in which other alternative is not possible, okay? So in general here you could see the the energy model that have been defined, okay? Of course, the main resource should be the renewables energies. The conventional generation should be like the support when we cannot integrate power in the system. We need this solution, okay? Until we could reach this moment in which the renewables energy could be enough, okay? So the energy that could be integrated in the electrical system, perfect. The other one, that is the surplus, can be used to recover, well, to storage energy, you know, with the pumped hydropower station, with batteries, but also with the hydrogen, because through this hydrogen, we can decarbonize this sector, as you mentioned, as we mentioned before, no? So the numbers in 2030 should be like that, okay? We have to increase the power capacity until 3,400 megawatts, more or less. For that, as I mentioned before, we have to increase around 200 megawatts every year the power capacity that we install in renewables energies, okay? Here you have also the number of vehicles that we need to decarbonize with electric vehicles and also with hydrogen. Here you have the hydrogen. So, well, I am not going to explain all the numbers because it's a lot, but you could see more or less like a picture in which you have like the main values for all, no? So at the end, if we reach this objective, we could obtain these results in our energy system, no? First of all, the low demand coverage with renewables energies could be around the 62%, okay? And also for the energy sector, as a global value, we could reach the 29%, okay? The greenhouse emissions could be reduced in the 50% of the total emissions that we have nowadays. If we compare with the Kyoto Protocol, the value will be around 2% of the value that we have there in this moment, I mean. And here you could see the numbers of the total investment in the first period and in the total until the total decarbonization of the Canary Islands, no? That is more or less the general numbers, no? So when we speak about the hydrogen, we could say that here in the Canary Islands, we have 5 main final uses that are interesting, okay? From our point of view, the first one could be the road heavy transport sector. Now we are going to explain why within that. Also the air transport sector, the marine transport sector. Also for re-electrification in locations where you don't have the possibility to install a wind farm or photovoltaic plant. And finally, for energy storage applications, okay? So in the road heavy transport sector, from our point of view, is a good alternative, because at the end, the alternative could be the use of the electric vehicles. And if you go, for example, in a bus, okay, mainly for this kind of vehicles, you need around 600 kilowatts, the battery of this system, okay? So to charge this kind of vehicles, you need a fast charger from more or less 50 megawatts. That's the time that you need for that is around 12 hours. We have the option to install other fast chargers, because now we have models that could reach until 200 kilowatts. You can reduce the time to charge this kind of vehicles until 3 hours, but at the end you have to install these fast chargers in locations that are not ready for the installation of this big power, no? So it seems more logical to install an electrolyzer in a place where you know that you have a wind farm, a photovoltaic plant, and transport this hydrogen to refueling stations where you could, well, use this new fuel, okay? And of course, in a time, you recharge or refueling the vehicle in less than 9 minutes. So it's a good opportunity for this sector. Also, we have analyzed the cost, no? And we have estimated the cost parity. The cost parity is the price at which the client will be willing to pay. I mean, if you know the price of the diesel, you could know the price at which you should or you could sell the hydrogen to pay the same at the end of the month, no? So if you analyze that, here you have an example. This is the current situation here in the Canary Island. The price of the diesel in the Canary Islands is 1.5 euros per liter, okay? You can estimate the cost of the hydrogen to pay exactly the same, and it's around 10 euros per kilogram. That is a value that we think that is profitable, okay? And it's nice if you want to decarbonize the transport sector. It's now something that we can do, because the cost to produce the hydrogen here in Canary Island is around 7 euros per kilogram, more or less. So this is the current situation, but the more normal situation is the one that you have here, around 0.95 euros per liter, no? So here you have all the values and also the different type of vehicles. So we think that that technology could be interesting for the transport sector nowadays, no? For the electrification is also a good alternative, mainly in these locations where you know that you want to decarbonize, but you don't have the capacity to install a wind farm, for example, near to a hotel or something like that, okay? In these cases, or in the middle of the natural protected area, you can produce the hydrogen in a specific location. When you have a offshore wind farm, for example, or a wind power, well, a wind farm that you could have there, and transport this hydrogen to locations where, you can decarbonize this system using the energy produced in another place, no? So it's a good alternative too, no? The problem is the efficiency. The efficiency is a little bit worse or bad in comparison with other possibilities like the batteries. It's more or less the 33%, okay? If you take into account the energy that you introduce in the electrolyzer and the one that you can recover with the fuel cell. And also we have analyzed it from the economical point of view, this problem, no? As you could see, if we change the hydrogen or you use the hydrogen to produce electricity, the hydrogen should have a price of around 2 euros per kilogram. But if you use also the application for combined heat and power, you could reach until 4 euros per kilogram, no? Okay. Another topic that could be interesting is the marine transport sector. I'm not going to explain that because are going to be explained by Salvador in his presentation. But at the end, it's a good alternative because you can optimize the space in the marine transport sector. You can use the ammonia that could be transported in liquid, okay? Of course, you have some problems too that should be solved. In this kind of problems, we are trying to analyze with the project BIOGREENFINERY, as we will explain in the next presentation. And we have analyzed it also from the economical point of view, and as you could see, more or less, the cost of the hydrogen is lower, so it's not too much profitable nowadays, okay? Should advance this market, but it's a possibility that we have for the future. At the end, we have analyzed it in the same way all the possibility that we have. Here in this part of the presentation, we have the price at which the customer will be willing to pay. And here is the price that we have estimated at which we need to produce. I mean, if we take into account the investment cost in the Canary Island, but also we know, for example, the maintenance cost and also the renewables energies in a wind farm, the total capacity that we can obtain, you could see that some applications are profitable nowadays if you compare both values, and others that are near and others that are far, but could be an alternative in the future, no? So at the end, this is the economical aspect is important, but also from the electrical point of view, the electrolyzer could be used as a way to apply some demand-side management strategies, okay? For the electrolyzers that we have analyzed until now, we could have a capacity to control the system in a range of between the 20% of the total capacity until the 100%. So you can apply some demand-side management policies. Of course, you have to take into account the balance, okay? Because it's something that is expensive, okay? And maybe you cannot cut the system, like a desalination plants or something like that, okay? So in the framework of the hydrogen strategy, we have analyzed first of all the demand of hydrogen that we will need to decarbonize the Canary Island energy system. And also we have analyzed the locations, possible locations where we could install electrolyzers in the Canary Island, using as a reference the locations of the substations, okay? So according with that, we have estimated these values for 2030 and for 2040, okay? Of course, maybe the road transport sector is the one in which we will need more hydrogen, okay? And also we have estimated with all these locations, you could enter in the website of the Observatorio Energético de Canarias, or ECAN, where you could download these documents. There you will see all the procedure and also the possible installations that we have estimated for all the islands, okay? And here you could see more or less the difference, okay? We need to produce a little bit more than the demand that we have, no? And also we have represented in this last slide the power that we will need in each island, okay, to decarbonize using as a vector, energy vector, the hydrogen, no? So as you could see, it's something complex, but not impossible. We should advance on that, and of course, this kind of projects, like the one that we are analyzing today, could be a good reference for the future. Thank you very much.
Thank you, Santiago. Santiago went over the very comprehensive strategy we have developed for the Canary Islands, dealing on trying to introduce hydrogen as this energy carrier for decarbonizing road transport and also for doing energy storage. What we'll do, we will leave the questions for the speakers for the end of the session. So our next speaker is Carlos Navas from Enagas Renewables. Carlos, okay. Thank you. Well, thank you. Good morning, Carlos. Well, Carlos Navas, he joined Enagas in 2020, heading the management of hydrogen projects, and Enagas Renewables became a subsidiary of Enagas in 2021. He's heading since then the strategy for regulatory affairs. He has been very active over the years. He joined fuel cells and hydrogen joint undertaking since 2010, has worked on the transport refueling infrastructure until July 2016. He also has supported at the beginning of his career some startup companies in the States. He joined as a senior research scientist working on at the energy-related devices in Los Alamos, New Mexico, and he also became Chief Technology Officer at NTDA Energía. It's in Valencia. And Carlos, well, he has a bachelor degree in chemistry and mathematics from Clark University, and his PhD from MIT, from the Massachusetts Institute of Technology in inorganic chemistry. Carlos, bienvenido. Welcome to ITC Installations, and please, the floor is yours.
Muchas gracias.
Sorry, Carlos, one last comment. We are short of time, so we have 20 minutes for each speaker. We were thinking maybe 15 minutes for a presentation and have some minutes for a question, but you have 20 minutes, but let's try to not go farther, just to keep the program on time. Thank you, Carlos.
Okay, I'll do my best to comply with this. If I speak too fast and people don't understand me, by all means, fault is yours. So thanks for the introduction and thanks for the invitation to participate here. We are presenting here the Power to Green Hydrogen Mallorca, the Green Hysland project. First thing I should do is acknowledge support by the Clean Hydrogen Joint Undertaking for funding that's provided through the Call 2020. The grant agreement reference is there. What I want to do today is just give you a little bit of a background on how the project got to the point where it is today, how it was born, and then just let you know a little bit of the main bits and pieces of the overall project and how we're progressing in putting them together. The drivers of how the project came together is, well, I won't say it's a funny story, but it's basically just, it has really three main components to it. One is run-of-the-mill, everyday life kind of thing. A cement plant is closing down, and as the cement plant closes down, then the local authorities get a little bit worried about losing jobs and losing capacity, losing workforce, and losing an opportunity to do something else with that plot of land, the capacity and the ability, the assets that you have there. So that's one part of it. At the same time, the island of Mallorca, and I think much as it is here in the Canary Islands, is very much concerned about the energy mix. It's very much used or based on fossil fuels. And in doing so, wants to take a look at how to decarbonize it, and the Balearic government has been quite active in promoting a decarbonization pathway over the next few years. And they wanted to do something on renewable energies, and potentially hydrogen was one part of it. So that was one option that came to the table. And a number of actors came into the mix to see if something like that could actually be born, to demonstrate how hydrogen could actually put something together. And the last bit of the mix, if I can put it that way, is much like the Canary Islands. The island of Mallorca is a tourist destination, has a very high visibility, so this is where we have a lot of synergies, I would say. And in so doing, you can actually have a lot of visibility and showcasing what a hydrogen ecosystem can do, and how it can provide some solutions at a pilot scale, clearly. But this is how the project was born, and this is the schematic of the overall project. We have new renewable energy capacity through 2 PV plants that are being put in the project. I'll show you how they are. That essentially feed green electricity to a hydrogen production plant of 2.5 megawatts, producing about 300 tons a year. And then that hydrogen is then transported to a variety of applications, some mobility, some, or what we would call stationary applications, and I'll show you how those are put together, and even including some hydrogen for injection into the local gas grid. We have a distribution gas grid on natural gas that is owned and operated by Redexis. So we also want to do that and demonstrate how that's being put together along a new pipeline, hydrogen pipeline, small one, that will also showcase that possibility and do a bit of a proof of concept on the island. This is the overall geographic outlay of the main bits and pieces. Where you see 1 and 2 on the top side, that's Lloseta. This is the local municipality where one of the PV plants is put together, and where the cement plant was actually located, and where the hydrogen production plant is being built. The second PV plant you see a little bit farther away, and most of the hydrogen is going to be devoted to in the city of Palma and surroundings. There's actually one of the uses is in a local, is in the municipality of Lloseta, where they will use the hydrogen in a fuel cell for, I think it's a municipal building. This is a little bit the same schematic, just with some numbers attached to it. Don't want to get too much into it. There's too many numbers to go through them. But just to let you know, this overall scheme has an overall production of over 300 tons a year. A lot of it goes to grid injection. We would like to devote as much hydrogen as possible to non-gas grid injections, as you can imagine, but finding potential uses of the hydrogen that are not necessarily directly related or directly involved in the project is a little bit difficult, because there's not a whole lot of knowledge about the technology. We will have mobility applications that have to do with both a local bus fleet at the EMT, the local transport authority in Palma de Mallorca, and also some private car fleets. And then I will go through a little bit where we are with the project. These are the PV plants. There's 2 of them in Lloseta, 8.5 megawatts peak power, and the one in Petra, a little bit farther away. That was number 2 that I showed earlier on, 5.8. Overall, it's about 14 megawatts peak power of PV plants. These are already operational. These have been operating for a number of months. I think they came online in the spring. So the next bit of the value chain is the hydrogen production plant. We already carried out an inauguration ceremony back in the spring, in March, attended with, let's say, high-level authorities, the local government, and the regional government. Cristina Armengol was there. We also had the Minister of Ecological Transition, Teresa Rivera, CEOs, and all the high-level authorities that came there. That production plant will start producing and start becoming operational most likely around beginning of next year, by the way. So just, I'd say we're very much in the latter stages of putting it together. This is the way it looks. This is just a normal kind of a AutoCAD type schematic that shows you a little bit where the main bits and pieces are. It's a little bit more, I'd say, worked over than a normal 20 or 40-foot container where you can actually have an electrolyzer. We put together a lot more bits and pieces. It's a pilot production plant, and the hydrogen is produced and then compressed at a certain pressure, about 300 and 350 bar pressure, so that it then gets carried away by tube trailers by Calvera, so trailers provided by Calvera, and then taken to a variety of final user sites. One of them is this hydrogen refueling station. It's not built yet. This is just a schematic, and in fact, probably the final layout will be somewhat different. This is just a first shot at it. We will have both dispensing for 350 bar and 700 bar for buses, which work at 350 bar, and cars, which normally work at 700 bar. And we will have about half a ton of on-site storage capacity at the station. The station has already been procured, it's ordered, and should be operational sometime in the second half of next year, by the way. Some of the other applications, and I didn't have time because time constraints, and Melissa made a very good job of stressing the need to comply with time constraints. So I don't have time to go into the details on all of these, but just very briefly, on mobility applications, we have a fleet of buses. 5 buses have already been ordered by the local transport authority. They will start arriving probably January or February of next year, so just couple months away. And in fact, they're already contemplating expanding the fleet further with another 3 buses of 18-meter length, articulated buses, for local operations. They haven't done that procurement yet, but they're really much thinking about it because they've already received funding for the fleet of 5 buses, not only from the grant that we received from Europe, but also from the MOVES program that many of you may be familiar with. That's run by the Spanish government and IDAE. In addition, we have a fleet of fuel cell vehicles, some vans, some cars. Looks like right now we're going to have 10 vehicles, 3 vans, and 7 cars. That's spending, last minute procurement, documentation, putting it together, and so on. We foresee that there will be not much of a problem with the cars. Those are homologated and so on. We should get those in a few months' time. The vans, they're chosen, but they're not homologated yet. So that's going to take a little bit more time. But again, putting them together, procuring those and putting them in operation is probably going to be more a matter of when is the hydrogen refueling station going to be ready, rather than the availability of the vehicles themselves. On stationary applications, there are a couple of various sites. So one is at the Hotel Iberostar Hotel in Palma de Mallorca. That will be using hydrogen in a fuel cell for combined heat and power. As you can imagine, a hotel has uses for both electricity and hot water applications. We also have an additional fuel cell for a municipal sports center in Lloseta. That's the locality that will have the hydrogen production plant. And a fuel cell at the ferry station in the Port of Palma for providing electricity for local operations, so just kind of support. We're in advanced engineering stages of both the engineering layout, both at the hotel and the ferry station, and procurement should probably be launched very soon, within the next month or 2. And the last, but very much not least, is the hydrogen injection into the distribution network. That's the natural gas distribution network, which is being done by Redexis. They're also in the final stages of implementing that solution. There's some permitting issues. As you might imagine, some local people, when they have a hydrogen pipeline that they don't know anything about, they get a little bit worried about things, whether rightly or wrongly. It's a different thing. They get worried, and they have some questions about whether a hydrogen pipeline going through their land or close to their land is something they look forward to or not. So they have questions. It delays the process, and instead of having something, today, they'll have it tomorrow or a couple months down the line, whatever the case may be. We're pretty much advanced also on that part of it. And we foresee that the pipeline and the injection will be probably operational sometime in late spring, early summer of next year again. So that's the layout of the project. I want to emphasize just a couple of additional points. One is we're also doing a lot of things, putting a lot of effort in putting events like this one, basically, where we disseminate what we do and how we do it to try to, let everybody know what can be done, not to replicate everything as it is, because every place is different, so you're not going to be able to replicate, and you shouldn't replicate everything as it is done in this particular project, but at least learn a little bit what can or cannot be done, and ask questions. We're here to help, to disseminate, to let you know what problems we encountered, what did work, and hopefully everybody can do a better job in the next time around. We have a number of observer, let's say, communities already in the project, and we're introducing new ones into the project on a daily basis, well, let's say almost daily basis, but certainly constant basis, perhaps would be a better way of putting it. Some key figures, and I don't want to go through all of them, just a couple of them that I would emphasize. One is the avoidance or the environmental impact. By the end of the project, we hope to avoid about 21,000 tons per year of CO2 emissions. We are already implementing new employment. There is a commercial entity that has already been formed by some of the main promoters of the project, among them Enagas. And we already have one person working there, so that's new jobs, and it's female, by the way, so that's, say, affirmative action with gender equality. And at the same time, it's an estimated investment for the overall project of about 50 million euros, out of which we're receiving about 10 from the Clean Hydrogen Joint Undertaking and additional funding from IDAE for the PV plants in parallel. This project would not be happening without the help and support and collaboration of, we're 30 partners in the project as a whole. So you can imagine there's lots of things. A big thing, and the main part of it clearly, is putting the deployment pieces together, all the bits and pieces that I told you about, PV plants, the hydrogen, the electrolyzer, the hydrogen production plant, the end user applications, and so on. And at the same time, there are a number of other things we do on the dissemination side, also on studies for replication, building business model, putting together a hydrogen roadmap for at the regional level, and to try to, and we do put a lot of emphasis on this, to try to disseminate the learnings of this particular project as much as we can, so that this can hopefully trigger new hydrogen ecosystems, hydrogen valleys elsewhere in Spain and Europe and beyond. So that's it. You have some contact information there. You have also my email. If you have any questions, we'd be happy to help address those as best as we can. Thank you.
Carlos, I would like to thank you for the time. I mean, perfect timing. I mean, only 15 minutes, incredible, with all the information you have managed to convey. And well, it's he has told us about a very inspiring, I mean, very successful experience they are carrying out in Mallorca, and Mallorca might be able to position through this project as a lighthouse for all European island regions, seeking for a fast transition to decarbonize road transport sector, especially the road transport sector. And I don't know if any questions for Carlos. We have some minutes. Thanks for to his the way he approached his presentation. If not, we can go to the next. Okay, sorry, Simone, if you can also identify yourself, because well, I guess Simone, you know him well. Well, yeah, please identify the company you work for. Yeah, while he gets the microphone, Simone is from NL Green Power. Okay. Yeah.
Hello? Yes. I suspect everybody can hear you. Yeah, we can hear you. Not online. Sorry. no, they're new PV plants as well. The PV plants are new. But the PV plants is, I'd say, run-of-the-mill, standard operating procedure, if I can put it that way. PV plants have been built before in islands and in the rest of Spain, so I suspect that wasn't really a major issue. On the permitting, I would have to get back to you on the exact length. It was many months. And the person who was in charge of that permitting process probably would describe it, if he were here, as rather painful. That's probably the best way that I can put it. Permitting is a pain in the neck for the very simple reason that permitting in Spain has to go through a local filter. And people at the local level don't know anything about hydrogen. And they have to go through the standard law. In Spain, it's called Ley de Hidrocarburos. It does not correspond to anything that we do at all. And so when you tell somebody we're going to actually build a hydrogen production plant, they might think of steam reformer for like a refinery or something. That's not what we do. And to get them to actually realize what we are doing and to get them to sign their name on a piece of paper saying, I'm okay with all this, when you have a flammable, potentially explosive gas going around, it takes some time, as you can imagine. And unfortunately, I think this is one problem that we're going to have a bit of on a recurring basis, no matter where you do this. I don't know to what degree you can do something about it, but it was a painful experience, that I can tell you. If you like some more information, we've done some presentations where that was the focus of this. A colleague of mine did that, excuse me. And again, it was painful, and it took many months to go through. But it's done for the most part, I believe. I don't think there are any outstanding permits left.
Okay, thank you very much.
One last question, because we...
Sí. Hola, Carlos, encantado, un placer. Bueno, mi pregunta básicamente es porque en la toma de decisión están exigiendo para los fondos europeos los criterios de sostenibilidad, ¿no? ¿Ustedes el impacto lo están midiendo a nivel social de la oportunidad de empleo verde para este ecosistema que ustedes están planteando? ¿De qué forma se va a capacitar a la gente?
Okay. Please, Carlos, because we have on streaming people from other European island regions that, so I mean, the question has to do with sustainable criteria. If you are applying them for your project, I mean, you're looking for the impact, sustainable impact of the activities you're carrying out in Mallorca.
Thank you. Thank you.
So I'll respond in English if that's okay, for the benefit of everybody here and listening online. So the project was submitted to a call for proposals under the Clean Hydrogen Joint Undertaking of the year 2020. I'm looking at somebody who would know. And there are three criteria that go into it. One of them is impact. That impact has a variety of levels. Has to do with sustainability, has to do with environmental impact. It has to do with creating added value locally and beyond at the European level. And I'm probably leaving something else out of it. But you don't have the level of filtering like you would in the innovation funds, for instance. So that program, that specific program that I'm talking about where we received funding, doesn't apply the kind of very in-depth analysis that you would to like an innovation funds, where you have to go through a long list and a long process of providing that level of detail. We do have those criteria, we met those criteria, and we try to make sure that we comply with those criteria within the project. I already mentioned the environmental impacts, creation of added value. Clearly, we want to introduce some training programs. There are some partners in the project that are also introducing training programs to make sure that there's a workforce that can be prepared to answer any call on hydrogen-related equipment. So production, fuel cells, and so on and so forth. And that's also part of the project, although I didn't really have time to go through all of that in detail. So we do very much pay attention to that.
Okay. Thank you, Carlos. Well, if no more questions, I mean, we're running out of time. So our next speaker is Paula Martinez from Redexis. We have Paula, a very young engineer from the University Politécnica de Madrid. mechanical engineer, and he also has a master's in energy engineering from the Polytechnical University in Madrid. Well, Carlos, as a thesis of his master's degree, he worked on transport, distribution, supply of green hydrogen, production offshore. And well, he has been for a year now working in Redexis on innovation projects focusing primarily on green hydrogen. So please, the floor is yours. And Pablo,
okay.
Yeah, just begin,
thank you
please.
for the presentation. Good morning, everyone. Thank you for inviting me and for organizing such an interesting event. This is also my first time giving a presentation like this, so if I make any mistake, please be gentle and understanding with me. So at Redexis, we're involved in different innovative projects, and between these projects, there are those focused on green hydrogen. And that is why in this presentation, I would like to show you and explain our experience and knowledge regarding the administrative process for these kind of projects. First of all, I want to start by giving a little bit of context regarding the framework in Spain in this kind of projects, and later on I will focus on our experience within the Green Hysland project. Okay, so starting with the current European framework, in this slide you can see two images that we obtained as a result of the Higgs project. That is another European project where Redexis also participates and where we try to fill the gaps of knowledge regarding the injection of hydrogen in the gas grid, not only from the technical point of view, but also from the legal and regulatory one. The image on the far right is a map of that shows us the allowed hydrogen concentration for blending with natural gas in the transmission gas grid. And as you can see, this is something that is not unified in the different European countries. Like, for example, the maximum allowed concentration is 10%, and in Spain, the maximum allowed is 5%. The other image is shows us the current status of the hydrogen strategies in the European countries. And as you can see, most of them already have a defined strategy, and the ones that didn't have already one are in the process of developing it. So, which clearly shows us the global interest in hydrogen and their technologies. Before moving on, if you want to get into more detail and have more information about it, you can have it in the project website of the Higgs project. Well, as you can see, we have quite a diverse picture on the current status of national legal and technical framework regarding the implementation of hydrogen in Europe. In this situation, the European Commission is working intensively on the preparation of different proposals of legislation regarding hydrogen and also hydrogen injection in the natural gas grid. To accelerate this process, the European gas sector is working, is very active and shows big efforts to achieve and enable the use of hydrogen, like, for example, participating in different innovative projects like Higgs or Green Hysland. And now that I give a little bit of context for the European framework, I want to focus on Spain. Regarding the transportation of gas by pipeline, Law 34 of 1998 is the basis for the gas grid systems and its regulation. It mainly applies to natural gas, but also to other gas types, but only if it's technically possible and safe to inject and transport these gases into the gas grid. Since we don't have a specific mention of hydrogen in our actual regulation, in June 2020, there were published a Royal Decree 542 that includes hydrogen in the gas phase as a fuel gas, and also includes service station for hydrogen in vehicles in the gas phase. Regarding the injection of hydrogen in the gas grid, that is something very important for us. In September of 2011, there was a resolution of the Directorate General of Energy Policy and Mines that includes Protocol of Detail PDO1. In this protocol, according to this Protocol of Detail, the current maximum concentration for alternative gases in natural gas that can be injected in the transmission grid is 5%. This is the number that I just showed you a few slides before, and it's allowed to interpret that it will be also valid for hydrogen, but this protocol detailed mention alternative gases, but we consider is also valid for hydrogen. Currently, a revision of this PDO1 is ongoing, and we hope that it will introduce a few changes in this matter. Regarding the hydrogen green hydrogen strategy, we saw that Spain is one of the countries that already have a defined strategy that it was published in October of 2020. As we saw, we don't have a clear and specific regulation and procedure for hydrogen projects. So that is why the government has been trying to accelerate in solving this issue. And this year, in 2022, 2 royal decrees laws were published that includes modifications to the hydrocarbons law, that is Law 34 of 1998 that I just explained. In these 2 royal decrees laws, it identifies pipelines that connect renewable gases plants, like for example for hydrogen, to the natural gas networks as direct lines, and also introduce some points and establish them. Like for example, no execution authorization is required, the ownership passes to the producers, and so on. These 2 royal decrees laws completely changed the scenario that we had until now for hydrogen projects and how to process them. Like for example, the Green Hysland project started before these 2 royal decrees laws came into force, and if we were to start the project today, the procedure that we will have to follow will be completely different from the one that we actually did. This is why, this is because the Green Hydrogen project was a first-timer, so new to everyone, that is been opening the way and even anticipating the establishment of the necessary regulatory process. So we hope that with this project, not only us can learn from it, but also the authorities, and to have the necessary regulatory process. So now that I explained a little bit of the framework we have today, I would like to focus on our experience within the Green Hysland project. Just to remember that the procedure that I'm going to explain was before the royal decrees laws came into force. Now, just a brief context for the Green Hysland project. For Redexis, we have different tasks that are squared in green. One of them is the construction of the hydrogen pipeline that will transport the green hydrogen to the injection point. In this injection point, the hydrogen will be injected into the natural gas transmission grid of the island. The 2 other tasks are regarding the deployment of end users application, one for fuel cell powered vehicles in Palma, and the other one for the installation of fuel cell at a hotel also in Palma. In this slide, you can see the tasks for Redexis in more detail, and just to mention that this task involves the operation for 2 years of the infrastructures associated with the hydrogen pipeline, and also the application executed by Redexis. Well, I want to focus now on the processing for the hydrogen pipeline and the injection post, and that we thought is the more interesting part. And in this map, you can see the natural gas transport network of the island of the Balearic Island, and the red dot that you can see in it is the Sansono 1 station. This Sansono 1 is the post where the hydrogen will be injected. In this position, it interconnects the entire natural gas transport network of the island. That is why we choose this location. So starting now regarding the competence for the hydrogen pipeline, in accordance with Article 3025 of the Balearic Autonomy Statute, the autonomous community has exclusive competence in matters of energy transport, as long as the transport doesn't leave the autonomous community and their use doesn't affect another autonomous community, which is the case in this project. Moreover, the state doesn't have reserved for itself by any means of basic regulation. So in the end, the autonomous community of the Balearic Island will have exclusive competence to authorize the installation of the hydrogen pipeline. There is also a peculiarity in the Balearic Island, that is the existence of the Energy Sector Master Plan of the Balearic Island, which allows to identify the hydrogen pipeline as an installation of general interest and exempt us from the need for licenses. Regarding the injection post, as it is a primary transportation gas pipeline, it will be processed by the General State Administration, in this case, the Ministry of Ecological Transition. If the injection point were a secondary transportation gas pipeline, it would be competence for the autonomous community. So as you can see, we have to deal with two different competences to process these two installations. So we separate them in two different projects because we couldn't process them as one, and that is one of the difficulties that we have to face in this project. Regarding the processing procedure, as we don't have a specific procedure to follow for hydrogen installations, we could follow the one established in Law 39 of 2015. However, the autonomous communities, in the same way that for secondary transportation gas pipeline, they have been applying the Royal Decree 1434 of 2002. In this sense, the state itself recently included through another Royal Decree, Royal Decree 335 of 2018, a forecast that allowed the application of the procedure established in this Royal Decree 1434 for hydrogen pipelines. Therefore, the procedure that we have to follow and the one the autonomous community has been applying is the one established in this Royal Decree. Following the guidelines of the autonomous community, the project won't need an administrative authorization, but it will need a project authorization and also a DPU, that is the Declaration of Public Utility, that will be granted according to the regional regulation. Moreover, due to the length of the hydrogen pipeline and because it does not affect the Natura 2000 network, the environmental impact statement is also not needed in this project. For the DPU, Declaration of Public Utility, it can be requested and granted under Article 2 and 3 of Law 13 of 2012. Article 2 indicates that this kind of installation can be declared of public utility, and Article 3 details the DPU application process, which will conclude with a resolution of the competent General Director in matters of industry and energy. Finishing my presentation, I would like to show you a timeline for the hydrogen pipeline and the injection post with the most important milestone for each project. The green line is for the hydrogen pipeline and the yellow one for the injection post. The first thing we had to do was the presentation of each project that gives the start of the administrative process. For the hydrogen pipeline, it was presented in November of last year, 2021, and the injection points in January of this year, 2022. After the presentation of each project, the public confirmation for both of them is published in March for the hydrogen pipeline and in April for the injection post. This public information was published for the hydrogen pipeline in the VoIP, that is the Balearic Island official newsletter, and also in the press. And for the injection post, it was, apart from these two, also published in the VoIP, that is the state official newsletter. Okay, thank you. From this point, you can see that for the hydrogen pipeline, we have to take much more steps than for the injection point, and also took us more time. For the injection point post, we received the CMC report that is in September of this year, and we expect the MITECO authorization in December, at the end of this year. MITECO is the Ministry of Ecological Transition. For the hydrogen pipeline, this is where we face the most difficulties because from the moment this public information is published, the different affected agencies, because since it's a project that affects third parties, private properties, as Carlos explained, the different agencies have to submit a report for the authorities with their consideration regarding the projects, and if they don't have any consideration, they submit a favorable one. Since this was such a unique project and the first one to be made, the authorities wanted to all the agencies to submit a report no matter the time, because they usually gave 30 days for this phase. And this is why this phase took us such a long time, receiving the last report in October of this year. After the agency's report, we presented the project addendum this month, at the end of this month, in November, and we expect the Government Balear authorization by January of next year, And the last step would be the land releases that gives the start of the construction works, and we expect it between March and April of next year. And as you could see, this is a process that took us more than a year, and I can assure you not an easy one. And we hope that with this project, is the first one to be made, we hope the authorities could learn from it, and also us, to learn how to process this kind of hydrogen projects. And well, this is it from it, and thank you for your attention.
Thank you, Pablo. A very interesting view of all the problems associated with the regulatory framework on implementing hydrogen, especially the issue of feeding hydrogen into existing natural gas pipelines. That 5% is a heavy restriction, and an important one, because there are now projects in which Enagás is participating in ongoing negotiations with France for a gas pipeline from, I think, from Barcelona to Marseille, I think. I don't remember well, and the idea is to use that pipeline in the future also to transport hydrogen. So I mean, the importance of addressing all these regulatory issues that sometimes are more important as barriers than technical aspects. I mean, technology is there and it's more or less controlled by engineers, but bureaucracy is something that engineers cannot solve, okay? So thank you very much, Paul. I don't know, because we are just on time. If there's one short question, if not, we go for the coffee break. And yes, Melissa?
We do have questions online, so we can take these.
Melissa, if not, you can come.
No, okay, it's working. Are there any questions in the audience? One. Okay, and then we do have some questions online, so I think to be fair with online participants, we do have to take them.
Hello, I'm Enrique Girón from the Spanish Hydrogen Association. I have one very small question. You mentioned that there is different limits in the different countries for how much hydrogen you can blend with the natural gas pipe. Is that a technical problem or is it a regulatory problem? I mean, do the pipelines in Germany, are they much different from the ones in Spain? Or is it just a question of they have more trust in their system?
Yeah, this is something that we are doing in the Higgs project, and we are trying to investigate it. Since there is some difference too, like you mentioned, in the pipelines that they use, for example, in Germany, and the ones that we use in Spain, and also not only from the pipelines, but the other equipments in the other countries. So because of the materials and everything, then sometimes they use different ones. So it's also a technical problem, issue that we are trying to investigate, and only for this equipment, and also because some of them doesn't admit much more concentration of hydrogens today. They have to change some parts of the installation that we have right now. And so this is a technical issue and also a regulatory one, but because, for example, in Spain, as is explained, it's allowed for alternative gases, but it doesn't specify for hydrogen. So we can think it's also valid for hydrogen, but in some countries there is no specific regulation for hydrogen. So it's a mix of both, a technical issue and also for a regulatory one.
So thank you, Pablo. And well, we see that Mallorca is not only allowing for showcasing different technology solutions for make integrating renewables hydrogen and using hydrogen not only for transport, but also for power generation, distributing into these pipelines. And that Mallorca, besides that technical showcase, is also helping, is being used as a regulatory sandbox. Will allow also to look for those solutions for overcoming those regulatory barriers, hopefully, that we also need to overcome in order to be able to develop this island, this energy, these hydrogen economies in European islands. Thank you, Pablo, and we can go now out for
Do
coffee
we have
break,
time
Melissa?
for two
have
small
time?
questions for
Very
online
short.
audience?
Okay, very short questions, yes.
Very shortly. There were two small questions for Santiago. When you mention technology for large-scale storage, what do you have in mind? And who is the island who is pioneer in hydrogen technologies in the Canaries?
Well, that is a difficult question because, in the case of the Gran Canaria, we will analyze in the presentation of Salvador, but the first project was installed here in Gran Canaria in 2007, okay? After that was installed another one. Another one is in Aldea, another one in Tenerife, so it's a difficult question. And regarding the storage, I think that it's important to know which kind of use you will have, no? Because in some cases you can install these storage systems near to, for example, a hotel, but if you are thinking more in the transport sector, maybe we have to define the locations where we have to install that. So it's not it's similar to the one that we have nowadays with the conventional fuels, okay? But will not be the same, okay, in the future.
Okay, I think we can close here because everybody needs coffee. Thank you.
Green Hysland will generate, distribute, and use at least 300 tons of renewable hydrogen locally per year. It will be produced by an electrolyzer which uses solar energy in the island of Mallorca. This green hydrogen will have multiple applications. It will be used in buses and vehicles. It will be used to heat and to use for power purposes in the island of Mallorca. And it's going to be part of the hydrogen is going to be injected in the distribution network in the island of Mallorca.
Es un proyecto palanca, puesto que reúne tanto a la transición energética, a la reindustrialización, a la diversificación y a la modernización de la estructura productiva, siendo estos ejes estratégicos para el futuro económico de las Islas Baleares.
We decided to join this beautiful project because we believe that Chile has a lot to offer to the hydrogen economy and much to learn from this practical experience. We are convinced that the consortium established is a strong group of public and private entities that will successfully accomplish all the goals, and we want to be part of it. So this experience will help us bring important and practical know-how, study the feasibility of carrying out something similar in one of our largest islands, such as Chiloé.
First of all, if you calculate all the people on all the islands in Europe together, then I think it's the 5th or the 6th biggest member state of the Union. So we need to decarbonize also the islands. Secondly, so far, hydrogen has not been really tested on islands. It's pretty new for islands, and we believe that hydrogen has a big potential to decarbonize the islands.
The Green Hysland project will bring to Madeira the opportunity to cooperate with other regions and to follow what is being done on hydrogen technology for energy storage, to increase the capacity to have more renewable energies in the electric system. I see these projects also as an opportunity to show the islands as laboratories and also test beds for new technologies.
Las islas debemos ser conscientes de que hemos de tomar la delantera en esta transición energética y aprovechar nuestra realidad insular para llegar cuanto antes a la soberanía energética y a la neutralidad climática, anticipándonos así a los retos que tiene también planteados el resto del continente europeo.
This will be, I'm sure of that, a blueprint for the so-called hydrogen island and an example to promote this type of renewable energy in other parts of Europe. Green Hysland will generate, distribute, and use at least 300 tons of renewable hydrogen locally per year. It will be produced by an electrolyzer which uses solar energy in the island of Mallorca. This green hydrogen will have multiple applications. It will be used in buses and vehicles. It will be used to heat and to use for power purposes in the island of Mallorca. And it's going to be part of the hydrogen is going to be injected in the distribution network in the island of Mallorca.
Es un proyecto palanca, puesto que reúne tanto a la transición energética, a la reindustrialización, a la diversificación y a la modernización de la estructura productiva, siendo estos ejes estratégicos para el futuro económico de las Islas Baleares.
We decided to join this beautiful project because we believe that Chile has a lot to offer to the hydrogen economy and much to learn from this practical experience. We are convinced that the consortium established is a strong group of public and private entities that will successfully accomplish all the goals, and we want to be part of it. So this experience will help us bring important and practical know-how, study the feasibility of carrying out something similar in one of our largest islands, such as Chiloé.
First of all, if you calculate all the people on all the islands in Europe together, then I think it's the 5th or the 6th biggest member state of the Union. So we need to decarbonize also the islands. Secondly, so far, hydrogen has not been really tested on islands. It's pretty new for islands, and we believe that hydrogen has a big potential to decarbonize the islands.
The Green Hysland project will bring to Madeira the opportunity to cooperate with other regions and to follow what is being done on hydrogen technology for energy storage, to increase the capacity to have more renewable energies in the electric system. I see this project also as an opportunity to show the islands as laboratories and also test beds for new technologies.
Las islas debemos ser conscientes de que hemos de tomar la delantera en esta transición energética y aprovechar nuestra realidad insular para llegar cuanto antes a la soberanía energética y a la neutralidad climática, anticipándonos así a los retos que tiene también planteados el resto del continente europeo.
This will be, I'm sure of that, a blueprint for the so-called hydrogen island and an example to promote this type of renewable energy in other parts of Europe. Green Hysland will generate, distribute, and use at least 300 tons of renewable hydrogen locally per year. It will be produced by an electrolyzer which uses solar energy in the island of Mallorca. This green hydrogen will have multiple applications. It will be used in buses and vehicles. It will be used to heat and to use for power purposes in the island of Mallorca. And it's going to be part of the hydrogen is going to be injected in the distribution network in the island of Mallorca.
Es un proyecto palanca, puesto que reúne tanto a la transición energética, a la reindustrialización, a la diversificación y a la modernización de la estructura productiva, siendo estos ejes estratégicos para el futuro económico de las Islas Baleares.
We decided to join this beautiful project because we believe that Chile has a lot to offer to the hydrogen economy and much to learn from this practical experience. We are convinced that the consortium established is a strong group of public and private entities that will successfully accomplish all the goals, and we want to be part of it. So this experience will help us bring important and practical know-how, study the feasibility of carrying out something similar in one of our largest islands, such as Chiloé.
First of all, if you calculate all the people on all the islands in Europe together, then I think it's the 5th or the 6th biggest member state of the Union. So we need to decarbonize also the islands. Secondly, so far, hydrogen has not been really tested on islands. It's pretty new for islands, and we believe that hydrogen has a big potential to decarbonize the islands.
The Green Hysland project will bring to Madeira the opportunity to cooperate with other regions and to follow what is being done on hydrogen technology for energy storage, to increase the capacity to have more renewable energies in the electric system. I see this project also as an opportunity to show the islands as laboratories and also test beds for new technologies.
Las islas debemos ser conscientes de que hemos de tomar la delantera en esta transición energética y aprovechar nuestra realidad insular para llegar cuanto antes a la soberanía energética y a la neutralidad climática, anticipándonos así a los retos que tiene también planteados el resto del continente europeo.
This will be, I'm sure of that, a blueprint for the so-called hydrogen island and an example to promote this type of renewable energy in other parts of Europe. Green Hysland will generate, distribute, and use at least 300 tons of renewable hydrogen locally per year. It will be produced by an electrolyzer which uses solar energy in the island of Mallorca. This green hydrogen will have multiple applications. It will be used in buses and vehicles. It will be used to heat and to use for power purposes in the island of Mallorca. And it's going to be part of the hydrogen is going to be injected in the distribution network in the island of Mallorca.
Es un proyecto palanca, puesto que reúne tanto a la transición energética, a la reindustrialización, a la diversificación y a la modernización de la estructura productiva, siendo estos ejes estratégicos para el futuro económico de las Islas Baleares.
We decided to join this beautiful project because we believe that Chile has a lot to offer to the hydrogen economy and much to learn from this practical experience. We are convinced that the consortium established is a strong group of public and private entities that will successfully accomplish all the goals, and we want to be part of it. So this experience will help us bring important and practical know-how, study the feasibility of carrying out something similar in one of our largest islands, such as Chiloé.
First of all, if you calculate all the people on all the islands in Europe together, then I think it's the 5th or the 6th biggest member state of the Union. So we need to decarbonize also the islands. Secondly, so far, hydrogen has not been really tested on islands. It's pretty new for islands, and we believe that hydrogen has a big potential to decarbonize the islands.
The Green Hysland project will bring to Madeira the opportunity to cooperate with other regions and to follow what is being done on hydrogen technology for energy storage, to increase the capacity to have more renewable energies in the electric system. I see this project also as an opportunity to show the islands as laboratories and also test beds for new technologies.
Las islas debemos ser conscientes de que hemos de tomar la delantera en esta transición energética y aprovechar nuestra realidad insular para llegar cuanto antes a la soberanía energética y a la neutralidad climática, anticipándonos así a los retos que tiene también planteados el resto del continente europeo.
This will be, I'm sure of that, a blueprint for the so-called hydrogen island and an example to promote this type of renewable energy in other parts of Europe. Green Hysland will generate, distribute and use at least 300 tons of renewable hydrogen locally per year. It will be produced by an electrolyzer which uses solar energy in the island of Mallorca. This green hydrogen will have multiple applications. It will be used in buses and vehicles. It will be used to heat and to use for power purposes in the island of Mallorca. And it's going to be part of the hydrogen is going to be injected in the distribution network in the island of Mallorca.
Es un proyecto palanca, puesto que reúne tanto a la transición energética, a la reindustrialización, a la diversificación y a la modernización de la estructura productiva, siendo estos ejes estratégicos para el futuro económico de las Islas Baleares.
We decided to join this beautiful project because we believe that Chile has a lot to offer to the hydrogen economy and much to learn from this practical experience. We are convinced that the consortium established is a strong group of public and private entities that will successfully accomplish all the goals, and we want to be part of it. So this experience will help us bring important and practical know-how, study the feasibility of carrying out something similar in one of our largest islands, such as Chiloé.
First of all, if you calculate all the people on all the islands in Europe together, then I think it's the 5th or the 6th biggest member state of the Union. So we need to decarbonize also the islands. Secondly, so far, hydrogen has not been really tested on islands. It's pretty new for islands, and we believe that hydrogen has a big potential to decarbonize the islands.
The Green Hysland project will bring to Madeira the opportunity to cooperate with other regions and to follow what is being done on hydrogen technology for energy storage, to increase the capacity to have more renewable energies in the electric system. I see this project also as an opportunity to show the islands as laboratories and also test beds for new technologies.
Las islas debemos ser conscientes de que hemos de tomar la delantera en esta transición energética y aprovechar nuestra realidad insular para llegar cuanto antes a la soberanía energética y a la neutralidad climática, anticipándonos así a los retos que tiene también planteados el resto del continente europeo.
This will be, I'm sure of that, a blueprint for the so-called hydrogen island and an example to promote this type of renewable energy in other parts of Europe.
David Capapey is project manager in Calvera. He is expert in management of projects related to hydrogen technologies and especially in supply storage solutions, compressor systems, transportation and high pressure gas supply. So welcome. He is going to speak about the storage and the transport of high pressure of hydrogen now. The floor is yours.
Now it's work. Yeah, thank you very much. Thanks for inviting me. First of all, I would like to introduce a little bit of Calvera because it's a familiar business with more than 40 years of experience. And oh, sorry, I don't know. Yeah, okay. Yeah. No, okay, perfect. We have more than 40 years of experience in hydrogen, and I would like to emphasize that we started as a really small welding company, and since then we evolve, we grow, and into what we are do today. That it's a company with almost 100 employees. We are experts in manufacturing and design all the equipment needed for the hydrogen transition. That is the dispenser, that is the uploading system, that is the storage, tube trailer, hydrogen stations, and the integration of all the equipment needs. We can achieve that because we invest a high portion of our revenues in investigation, and that gives us the opportunity to adapt quickly to that the market requires and offer the best solutions to our clients. And we are located in Zaragoza, Spain. This slide represents very well what is our scope currently when we are talking about the hydrogen stations. Okay, we can supply all the equipment needs that the client needs after the electrolyzer. That's the storage, the hydrogen compression station, the different dispensers, and something that we need to know is the vehicle that we need to refuel. Okay, it's not the same refuel a light vehicle, a heavy vehicle, a train, or forklifts, buses. We have to take into account different kind of things, and the configuration of the hydrogen station could be different. Okay. Also, we are specialized in smart filling panels to reload tube trailers. These tube trailers, as you can suppose, we design and manufacture them with different range of pressures. We are not manufacturer of cylinders, but we work with all kind of type of cylinders that we have in the market. We use one of them, depending on the client needs. So we choose always the better solution. Ones are cheaper, but have some advantages. And now I would like to talk about some real projects that we are involved relations with the hydrogen. This one is the Europe's largest capacity tube trailer that we did. For achieve that, we have to use type 4 cylinders. And as you can see in the picture, we achieved the largest capacity. We have to put the cylinders in some places a little bit unusual, under the chassis, for example, or at the beginning of the chassis, they are a little bit outside of the chassis. We need to tricky challenges because we have standard tube trailers, but also according to the needs of our clients. We can do changes because our experience is really high, but when we close a project, we analyze that, and we always have tasks to improve the tube trailers with the manifold, the valve panel, different ways to improve our designs according to the client needs and the market goals. This one is a little example that an hydrogen station could be for the light and heavy vehicles. Here we can see different storage. Okay, with we will need the storage for 300 bars, 500 bars, 1,000 bars, the compressor, the dispenser, all this equipment, we supply them, and we do the integration of these equipments in order to guarantee that the installation is safety and there is no problem in the integration between the equipment. Also, on the left, we can see a tube trailer. This is because the electrolyzer could be in another location. So to transport the hydrogen and supply the hydrogen to the hydrogen station, we will use these tube trailers. And another project is the hydrogen station for buses in Barcelona, and that represents very well that our way to work in each project, because we study carefully each project. Nowadays, the hydrogen project is starting. Some laws are not defined, and something and a little bit of, and we apport our knowledge to help our clients to find our best solutions and the needs that they have. In this case, this bus hydrogen station needs to reload up to 60 buses. Okay, but in the project, they first buy 8 buses. So the way that we did this project is to start to manufacture and to implement the equipment needed for these 8 buses. Okay. Then we divided the project in different phases. When our client buy more buses, 16, 26, 60 buses, we manufacture the equipment needed, and we can add this equipment to the actual hydrogen station. Okay. For example, in the second phase, we will need more medium pressure storage. We will need more dispenser, and we can do all of that. The last example of our projects is the Surf and Turf project. It's a European project, a pioneering project producing, distributing, and storage green hydrogen. And we provide to this project with free mobile storage that they supply the hydrogen, they transport the hydrogen from the different islands in Orkney, from the island of Scotland. And that's kind of mobile storage could help us in order to have a mobile hydrogen station if we want, or it's a really versatile equipment. And all this experience that I talked before help us to become part of this great project, the Green Hysland project. And as all of you know, due to the previous speakers, the Gran Hysland project, we have a production plant of the hydrogen, and we need to transport this hydrogen to the different end users around the Mallorca island. How we achieve that? Because Calvera supply to the project with 2 tube trailers. It's 300 bars and 30 feet of length. And his goal is to transport the hydrogen and to the hydrogen station, to the hotel, Port of Palma, and the rest of the different end users. As we said before, these tube trailers, we can supply different kind of designs, and depending on the requirements of the project, we use different materials. After, we saw a tube trailer with cylinders type 4. In this case, we use cylinders type 2. And we adapt the design according to the project needs. Inside the Green Hysland project, we also supply 2 more equipment, in particular for Port of Palma. Here, we supply, for one side, the storage needed to the needs for this end user. Okay, this storage, and it's an important thing that is a little bit modular. That means that is in the future the requirements is higher. We can increase the storage easily. We only have to add more storage, and the manifold could require a little modification. In addition, we also are manufacturing, supply an uploading panel. The goal of this uploading panel is to reload the storage from the tube trailer, and at the same time supply the hydrogen to the fuel cell. As you can see, the integration, when you are talking about an hydrogen project, is really important, the integration of all equipment, because a silly thing that is the connector, if you not take into account this little thing, you could have a lot of problems, and that's something that we have to take into account, and with the integration of all of equipment, we guarantee that the work works right. And I think that concludes my presentation, and if you have any doubt, let me know.
Thank you very much, David. I think that is a really interesting part at the end, because we always speak about the electrolyzers, and maybe could be the first part, but it's important too, no? All the parts related to the storage, and also the compressor of the hydrogen, no? I don't know if someone have any question here in the audience.
Thank you for the presentation. I have a couple of quick questions on, not on the project-related part, but rather on your own company. You showed 2 examples, one on the refueling station in Barcelona, and your own experience in the mobile refueling station. Related question for both. Are they both ready to refuel private vehicles, cars, at 700 bar?
In Barcelona is not ready, it's for buses, only for buses at the moment. And the second one, now I don't have I think that for vehicles, 700 bars, not yet. But we have another hydrogen station in Madrid, for example, that is working at 700 bars.
We know it well. We know well because we built that with your equipment. Do you know by when it is foreseen to have the Barcelona station refueling vehicles, private vehicles, cars at 700 bar?
We have not that information for our client, so at the moment we know that the hydrogen station is increasing the storage, and the bus fleet, but about vehicles, I cannot answer that.
Well, I guess the other way to ask the question is, do you have, since you're providing the storage, do you have the high pressure storage already installed at the facility?
Yes.
Okay.
Mi pregunta, what's about the possibility to have an explosion with hydrogen?
It's really strange. All our effort, we have a lot of engineers studying each case with calculation, with ATEX drawings with different kind of security matrix in order to be really secure that nothing's happened.
I think in the Zeppelin, Antes,
because the
great aeroplane in the air, which has an explosion. So this is also technology. Wow.
No, we have a great part of our engineering are calculating everything really carefully, and always we have discussions with our customers, our clients, in order to be sure that nothing's happened.
Yeah, I have a question about the storage levels. You know, why you have different storage levels, like 300, 500, and 1,000 bars, and you have different. I understand the different levels of fueling, but why don't you just use one storage level and then reduce the pressure for the fueling if you need it?
It depends on the vehicle that you want to refuel. For example,
No,
for
that's
vehicles,
for the fueling, but why do you have 3 different storage levels, you know, compressions? I don't understand that part.
because it's easier to storage 300 bars,
okay,
and cheaper, and then you have the compressor to different phases depending of the use. For example, for buses, you have a 500 storage, and for cascade, you can reload the bus, and the same for light vehicles.
Yeah, but you built 3 storage levels instead of just one, so that's my.
But I think
problem.
that's
in the end more expensive than if you build just one.
No, but I think that the efficiency is also important, because at the end, if you storage at 700 bars, no, and after that you reduce to 300 bars, no, you lost energy there, no, because you need a compressor that are going to be bigger.
It's usually that the tube trailer is around 300 bars. Okay, so when you reload the storage for the hydrogen station, when you need, as you said, you need a compressor, you need to achieve the better efficiency. So you have the buffer or the higher storage is for the 300 bars. And then you have a little storage for 500 bars and a little one for 9 or 1,000 bars. And they are ready to use when the bus or the vehicle come to be refueled.
I don't know if we can continue with that, or you want to do some questions from
I think it's
online.
time to. Okay, one more, and then it's really over. Sorry, we are over time.
Bueno, sabemos que la red en tubería tiene unas mermas importantes, y eso al final lo pagamos los usuarios finales en el recibo, ¿no? Aquí me parece que la solución es fantástica porque acorta la cadena de emisiones, y bueno, tan solo es saber si ustedes tienen alguna merma de gas hidrógeno, así como la hay en tubería por fugas en la red enterrada.
The pipeline.
Well, he's asking about the losses that we could have in the hydrogen, no, in comparison with the one that we have with the water, no.
There is no, when you transport the hydrogen, there is no any leak in the tube trailer and the manifold on the valve panel. However, you always lose something due to the loose load, but it's a little loose, not too much, as you can have in water or whatever when you transport something by ducts.
Thank you.
So, thank you very much. Now we can continue with the next presentation that are going to be developed by Ricardo Guerrero Lemos. Ricardo is he's obtained his first degree in physics in the University of Autónoma de Madrid, and also a PhD, where he served as assistant professor in the Department of Applied Physics. Ricardo is a full professor in the University of La Laguna and director of the Master Program of Renewable Energies in this university. He teaches about conventional renewable energies, regulatory affairs, power grids, energy efficiency, and he also founded 2 spin-off companies, Energy Risk in 2020 and AU Green Hydrogen in 2022. He has been CEO in the Canary Island Institute of Technology and visiting professor in several universities, University of Texas, also in the Solar Energy Research Institute of Singapore. And he also is board in the Technological Institute of Renewable Energies in ITER. And in Corona del Viento. So he's going to speak about one of the approach that is being implemented in the case of Tenerife. Ricardo, the floor is yours.
Thank you very much. Let me start the conversation saying that our role in this project is just starting. That means that in the beginning what we need is first to have the tool. The tool is being deployed or developed by the Institute of Hydrogen in Aragon. And our role is trying to define the replicability of the project of Mallorca in Tenerife. Tenerife and Gran Canaria are mostly twin islands, maybe in the future not so much, as in Gran Canaria it's expected that the hydro pumping system between Chira and Soria will start running, no? And Tenerife is still expected if at the end some pumping will be running also or not. And also our role in this project is to give some support to our partners in Morocco, because they are also partners in the project, and then we expect to start also a conversation with them. The aim of this presentation is mostly to explain how things are in Tenerife, also in the Canary Islands, and after that I will show some of the let's say the simulations that we have done with our algorithm that was also developed before into a project between Endesa, Enagas and the Port Authority of Tenerife, trying to understand how to produce hydrogen in Tenerife and how to also integrate the production of hydrogen in the power grid of the island. Well, first I want to show you some problems we have in our islands about the depth of the seafloor that we have between islands. That means that at the end the only power system that we have now connected are Fuerteventura and Lanzarote. And the line has been recently reinforced. And I understand that the work is running, I'm going to use this mouse. The mouse is, yes, between Tenerife and La Gomera. No? It's an interconnection between both islands. You have here, if you want to see some data about the capacity of the grid. I understand that is still this value. No? We are talking about an investment close to 100 million euros. That is a lot. And not expected, at least in the short term, to have other connection between islands. I have been hearing a lot about connection between Fuerteventura and Gran Canaria, but this connection is still not defined in the program of the Spanish government about transmission of energy between islands. And other things as the connection, the most powerful interconnection between Tenerife and Gran Canaria is, I think, is still not also in papers, no? But let me say that, in my opinion, no, as there is started a connection between Crete, Cyprus, and Israel. And we are talking about lines that go deep down to a couple of 1,000 meters. Maybe the interconnection between islands in the Canaries could have an horizon in the future to be integrated also. But this is a discussion. Also, maybe between mainland Spain and the Canary Islands could be an option, no? Because what we have seen in this project between Crete and Cyprus and Israel can be very similar to the kind of interconnection that we can have, no? But also let me say that the interconnections in the island doesn't mean that at the end, for example, if we talk about Tenerife and La Gomera, it doesn't mean at the end that La Gomera will be without any power generation, because it's something that can be not acceptable in terms of the risk that any problem with interconnections will bring to the Islanders in the future, no? Then interconnections means at the end a kind of partial supply, but still the islands need extra supply. Well, but at the end, let's say that in the short term, Tenerife and La Gomera could be interconnected, but La Gomera has only 20,000 inhabitants, and Tenerife has close to 1 million. That means that at the end, the interconnection between La Gomera and Tenerife doesn't represent for Tenerife anything really different of how things are going on now. Yes. Well, some information about the evolution of the generation in the different islands. At the end, yes, Tenerife, as it's the most populated island, is also the most power-consuming island, no? And the increase from 2020 to 2021 usually used to be very low, but this time, because of the COVID disease, then the increase has been larger, no? If you want to see the impact of the COVID in the consumption of Tenerife, maybe this graph can give you some idea about the impact of the disease and the reduction on the economic activity on this island. The coverage of renewable energies in Tenerife is mostly based on wind energy, also photovoltaics. I believe that photovoltaics is growing. We have some challenge in the near future, because there are some companies that want to introduce offshore wind energy in the islands, mostly in Gran Canaria, as it is a speedy way, no, to increase the share of renewables, but it's not sure that it will happen, because it depends also on the subsidies of the government. But my expectations are that photovoltaics, mostly in self-consumption on roof, will bring a huge increase of the production of renewables in the island, no? But at the end, have in mind that at least in Tenerife, we have no storage, no? Then that means that we have a very important challenge to define how to manage all the potential of renewable energies that can be around. That brings the role of hydrogen, a good option for being, let's say, a kind of member, no, in the mix or in the electricity supply of at the island, and also, of course, to other end users that are being defined in Mallorca, no, as hotels, transportation, mostly public, private, renting, whatever. This is a graph about the price of the cost, no, of the electricity in different power systems in the island. Sorry, because it's very small, but I can make you a small description, no? Because here, this is La Gomera. At this time, the most expensive system in the islands is La Gomera. Well, maybe also because El Hierro, Corona del Viento, has been paid some years ago, no? Because if we included the cost of Corona del Viento in the cost of the electricity every year, maybe the numbers will be a little bit different. We have some problems in the island, let me say, because some conventional power units are really old and not prepared for some European rules about the industrial emissions, and also some of them are old. And on the other side, we have the Plan Nacional Integrado de Energía y Clima. That means that we have a strong commitments for 2030. For example, to reduce the CO2 emissions to 50% of the emissions of the electric system in 2019. No? That's really very important, and that brings us to the question of how, a very urgent question on how to define the power mixed, not only in Tenerife, but in the Canary Islands, in the different power system in the near future. Important also, well, you have here the description about the capacity installed in Tenerife. And here is not the largest one, but very close to the largest one, the instantaneous integration of renewable energies in Tenerife. We got about 60% of instantaneous penetration of renewable energies in Tenerife in, I have no here the number, well, maybe I can show it, yes, here maybe. No. The percentage of renewable integrated in Tenerife, the record is 64% in 2021, in this day at 4 p.m. Without any storage. No? That means that is really an impressive number. And you have also the numbers for Gran Canaria, for Lanzarote, Fuerteventura, La Palma. No? At the end, that means that we have some curtailment. Some numbers are important. Some wind farms brings up to more than 10% curtailment each year. Because of the rules, we have some grid codes in the islands, maybe not very well defined up to this moment, because it was not, these kind of situations were not expected when the grid codes were defined, no? But the numbers are important. And Red Eléctrica is trying to keep the grid running with good health, and that means that curtailment is coming. Also, there is a problem with the value of the curtailment that is produced, because it's not very easy when you have not very well defined how it is working, but this is another matter. And these are some things that we have done in my group at the University of La Laguna, trying to show the integration of hydrogen in Tenerife. No? Then you can see here not only the integration of hydrogen, we also consider the introduction of batteries in the island. No? We have made a report from the University of La Laguna, trying to give some support to avoid blackouts. You know that we have had some blackouts in Tenerife in recent years, and we understand that it's very important to introduce also a large battery in Tenerife. We are talking about 50 megawatts hour of capacity in, no, I think, sorry, 50 megawatts, no, of batteries in Tenerife in terms of power and maybe in terms of electricity storage, maybe for working for 1 or 2 hours. And then we have tried to define the kind of electrolyzers we need and how to run it, because in these islands we have some seasonal variations, mostly of course in photovoltaics, no? Because in summer we used to have 40% more electricity produced than in winter, no? This is quite well balanced, no, compared with the north of Europe, and also in terms of wind energy, we used to have in September, October a very low resource, and in other months about the year. That means at the end we understand that we need some seasonal storage, and then hydrogen can be the best choice for introducing it to us. No? Here some details about how we are running these simulations. No? But still, as I said in the beginning, the project of Mallorca, no? Is still developing the tools for doing it also. No? And here we have done, sorry, I don't know what, yes. Some numbers about the levelized cost of producing hydrogen, also introducing information about the CAPEX and the OPEX needed with some definition that we have made. Yes. And more or less, I think that is all. No? Well, some numbers about the return, the internal return of the investment needed, and in relation with the price of hydrogen being sold in a wholesale market. And that's all. Thank you very much.
Thank you very much, Ricardo. A good vision of the situation of the Tenerife in the context of the energy. I don't know if we have time, well, one question or something like that to continue with the presentation. Some questions here? Oh, okay. So let's continue. Thank you very much.
Yeah, there was one question online, but actually I think you addressed it kind of. It was just, Ricardo, if you could tell quickly the electrical capacity in megawatts for the installed wind capacity and for PV in Tenerife and the future plans as well.
Sorry, the capacity that is currently installed, I understand.
And the future plans for wind and solar.
Okay. Currently installed in terms PV could be around 130 megawatts. In wind, it can be around 240 megawatts, more or less. But it's important the huge increase in self-consumption at this time, fueled by the subsidies of the government, no? And I believe that maybe in Tenerife we can have extra 20 megawatts of self-consumption also included, no? It's important to have also the data. And for the future, well, the PDCAN, no? the plan de decarbonización energética de Canarias is still in the process, no? But I understand that for 2030, expect for the different islands to go above 50%, no? Of the well, Salvador will talk later. 62%, no? A little bit more than 50. Yes, I hope so. Yes. But first we need to define a little bit more, because it's not so easy, and many people is pressing for having more space for placing the renewable, and we have a tradition in the islands to make plans, and at the end it's really very difficult, no? Then talking about the future is the scenario is very unexpected. Thank you.
Thank you. So thank you very much. Well, the next presentation will be done by Salvador Suarez. Salvador is the head of the Department of Renewable Energies of ITC. He is a PhD engineer and chemical environment engineer. And he also is managing a team of 40 people in this institution, okay, in topics related to the integration of renewable energies in small and insular electrical systems. In this presentation, he is going to explain the projects that have been developed by ITC in the last years, no? Topics related to the mobility and also in the energy storage. The floor is yours.
Thank you, Santiago. Okay, I'll try. I don't know how are we running with time, Santiago. We are on schedule. Okay, so you have 20 minutes. When we go to 15, please let me know. Okay, so I'll try to go fast anyway. Okay, before going into the experiences we have been developing at ITC with integration of renewables and hydrogen technologies, I would like to point out to a couple of things. First, I mean, if we look to the stoichiometry of the reaction in the electrolyzer to decompose the water molecule, what we see is that, one, we have a mole of water and we obtain 1 mole of molecular hydrogen, half a mole of molecular oxygen. We can see it also. I mean, if we have 2 moles, we will get 2 moles of hydrogen and 1 mole of oxygen. In terms of mass, that means that we need 9 kilograms of water to produce 1 kilogram of hydrogen. And when we see the energy balance, I mean, in theory, what the theory says is that we need 39.4 kilowatt hour per kilogram of hydrogen in both technologies, alkaline electrolyzers and PEM electrolyzers. What we have in reality, at least what we have been measuring at ITC, is 55 kilowatt hour per kilogram. That's an acceptable efficiency in electrolyzers. You might find more efficient electrolyzers, but of course some exceeding that consumption. And also, I mean, something that I want to point out here is the water issue, because we're talking about islands that the resource is scarce. We are desalinating about 700,000 cubic meters a day in the Canary Islands, easternmost islands, Gran Canaria, Lanzarote, and Fuerteventura. In the case of Lanzarote, 100% of the water consumption is from seawater desalination through reverse osmosis. So people are looking at that issue of water. I mean, 9 kilograms of water to produce 1 kilogram of hydrogen. But then if we look at the specific energy consumption of water desalination, we're talking about 2.2 kilowatt hour per cubic meter of water with water recovery systems. Okay, to produce 1,000 kilograms, you need 2.2 kilowatt hour. That means that you need 0.002 kilowatt hour per kilogram. If we need 10 kilograms, about 9 kilograms, for obtaining 1 kilogram of hydrogen, then in terms of energy, I mean, it's 0.02 kilowatt hour of energy. That's negligible when you compare it with all the energy input needed at the electrolyzer, even for compressing that hydrogen, okay? We're talking about 55 kilowatt hour at the electrolyzers. I mean, those 0.02 kilowatt hour for obtaining 9 kilograms of water is not really an issue, okay? So people sometimes are misguided. I mean, they're not really getting the picture right. Okay, and then another issue, okay, we're talking about not interconnected islands, as Ricardo has just mentioned, only Fuerteventura and Lanzarote are currently interconnected. So, I mean, integrating renewables in this not interconnected island is a very complicated issue. When we have these high penetration renewable scenarios, we will begin to get problems of stability. I mean, we're jeopardizing security and quality of energy supply. We're affecting especially a grid parameter that's called the frequency. Okay, we have too much energy generation, and we don't have, on the other side, demand. We will begin to experience a high frequency. We have to keep it in the 50 hertz, and we somehow have to curtail those energy generation systems, the wind farms, reducing our operating hours and affecting the cash flow of those projects. On the other side, if we don't have enough power generation at certain times, there's no wind, and we have a peak demand, then we have problems from the demand side. So we have to do load sharing, which is not also nice. I mean, there are non-critical loads that you can shed, but imagine a game like yesterday, Germany and Spain. If you don't have wind, you just cannot cut electricity supply to the people, because that's a real problem, okay? So, I mean, we need in the island systems non-critical, deferrable, dispatchable loads, and electrolyzers are perfect, okay? Electrolyzers in the two roles. The first role as energy, as hydrogen, as energy storage, okay? We will have this grid-connected electrolyzers producing hydrogen. We compress the hydrogen, we store in high-pressure vessels, and then we re-electrify that hydrogen through fuel cells to supply electricity when we have peak loads. So hydrogen will be playing a role in grid balancing, which is very nice for the system operator, in our case, Red Eléctrica de España, to have these non-critical loads connected to the grid. And the other role of hydrogen. Hydrogen as an energy carrier, we use the word in Spain of vector, no? Energy vector, for trying to put this wind and sun into vehicles, okay? So far, we have this technology, lithium-ion, which is proven to be an alternative for small cars, okay? But when we go to big, heavy vehicles, there's a problem there, okay? Because when we talk about a kilowatt hour of capacity of lithium-ion, we're talking about 4 kilograms, okay? The energy density of lithium-ion is about 0.25 kilowatt hour per kilogram. So if we want to store the 1 kilowatt, we need 4 kilograms. A car where you have, you are storing maybe 60, 80 kilowatt hour, you're talking about maybe 320 kilograms of batteries into the car for an autonomy of 400 kilometers, okay, it's heavy. But when we talk about a truck that might need 600 kilowatt hour a day, then we're talking 600 kilowatts times 4, we're talking about 2.4, almost 2.5 tons of batteries inside a bus, a bus or a truck. And that's too much. And then you have to charge that battery. Even fast charging at 50 kilowatt, you spend a lot of hours charging that battery. So, I mean, we have to look to other solutions, and hydrogen is perfect. I mean, it's not that ITC says so. The hydrogen roadmap of the European Commission to 2040 talks about the need of using hydrogen as a heavy vehicle road transport fuel, okay? And the time. And then we have here with specific consumptions in turn of 6 to 8 kilogram per 100 kilometers in those heavy vehicles. Okay, so let's now look, after clarifying those two issues, let's look at ITC experience, okay? We have been working since 2002 on hydrogen projects at ITC, doing several experiences here on site at our facilities in Pozo Izquierdo. We also have been working on different projects financed by the European Commission. For example, we had this project, Hydrabus, we carried out with our colleagues from Madeira, Azores, trying to estimate the amount of hydrogen that could be produced in scenarios, in ambitious scenarios of renewable energy penetration at low value hours at night, instead of curtailing wind farms. What can we do with that electricity? One option is having electrolyzers, making use of that electricity. We did some analysis, how many buses we could move in the case of Gran Canaria in a scenario of 1,025 megawatt of wind power installed. We could be talking about enough hydrogen to move a fleet of about 600 buses. Okay, then we went to our first project where we got our hands dirty. Okay, this was a project we started here in Pozo Izquierdo. Was a microgrid with a high penetration, 100% penetration of renewables. We installed an electrolyzer, a 55 kilowatt electrolyzer, producing 1 kilogram an hour. We also installed a 50 kilogram energy storage system, fuel cells, 30 kilowatt of fuel cells to re-electrify that hydrogen. And we had a dissipating load, a programmable dissipating load, emulating the demand from a remote village. And we tried to stabilize that microgrid using these hydrogen technologies, this electrolyzer and these fuel cells. And, well, the heart of the electrolyzer was this 55 kilowatt electrolyzer supplied by a Swiss company called Acagen. They were using patents from Casale. And we had this, was an alkaline electrolyzer producing very pure hydrogen. Well, it had a purified unit given 5 nines of purity to be able to use that hydrogen into fuel cells of 50% efficiency for the electrification. So we have 6 plug power fuel cells, each one with an inverter associated, and we created a 3-phase electric supply to fit the dissipating load, the programmable dissipating load. Okay, these were some pictures of all the work we had back then, installing the system. And the second project we carried out here at our installation was called Hydro Hybrid. This was, by the way, in this first project, we had different partners from different European countries, but in the case of Spain, we had Endesa and we had Abengoa, 2 companies in Abenza Green Cell. We have the INTA, which is the National Aerospace Technical Institution of Spain, and the local University of Las Palmas of Gran Canaria also participating in the project, was coordinated by ITC, and a second prototype was installed in the outskirts of Athens by our colleagues from CRES, the National Renewable Energy Center of Greece. Well, and then, as I was mentioning, we had the second project, the Hydro Hybrid, was a proof of concept for validating the concept of using hydrogen as an energy carrier to put the wind and the sun into a vehicle. It was a small project, only 10 kilowatt of wind and 3 kilowatt peak of PV, and we bought this electrolyzer from California manufacturer Proton Energy, the Hagen, which I think has been recently, well, I don't know if they merged, if it was bought by Nel from Norwegian manufacturer Nel, has somehow acquired this American company. And well, the Hagen was giving us very pure hydrogen, was a PEM electrolyzer. We got at 15 bar the hydrogen, we compressed at 200 by a booster compressor and put that hydrogen into a small vehicle that was supplied by us by a company in Madrid. It was an electric vehicle that they put a fuel cell on board. Currently, we are in a project in the northwest of the island. It's called, the place is called Aldea, Aldea San Nicolas. It's a very remote island. We don't have transmission lines getting to this place. We only have 20 kilovolt distribution line supplying power. So it's a very remote place. It's like an energy island within the geographical island of Gran Canaria. Perfect place for proving these technologies, hydrogen. So what we had is this farm is one of the biggest cattle farm of the Canary Islands, the biggest in Gran Canaria. They have 700 cows, but they are planning to go to 1,200. And what we did was we installed a PV system, an electrolyzer 1 kilogram, then a compressor for going to 200 bar, the fuel cell, a lithium iron phosphate battery of 100 kilowatt and 100 kilowatt hour capacity. And there was an existing diesel we're using it as a backup. And then we also adapted our forecasting modeling. We've been working for 15 years with forecasting now on WRF. So we also adapted all this forecasting for wind and solar to the farm. And what we did initially when we got there, they were running 100% diesel, even if they had this grid connected, but I mean, it was not too reliable. So they were just burning diesel to supply electricity to cover the demand of the installations. Then we installed a PV system, maintaining the grid connection for the excess electricity, and we came up with a solution to cover 40%. The next phase, we incorporated batteries. So now we were having this system running, a hybrid diesel PV battery system. We went up to 55%, and currently we are finishing installing, the system is already installed. We're finishing doing the final adjustments of the hydrogen technology and system to try to achieve penetrations between 75 and 80 in, I don't know, Santiago, maybe a couple of months, okay. And well, the main loads at this complex is basically the milking machinery and also the cooling for keeping the milk. Currently we have about 60 kilowatt of demand. 42 is associated to the milking, and now power demand is going to increase because they are planning to increase the cooling to total demand will be 100 kilowatt. Well, we installed also different weather data gathering systems that is the data being fed to our forecasting modeling to try to have reliable forecast of wind, solar, and temperatures at the place. And we develop also the energy management system of this microgrid. Basically, what we do is try to optimize from considering all the resources, all that data, all those forecastings we're doing, and also all those non-critical loads, especially the cooling, how we can manage that cooling through the energy management system to try to optimize, reduce the cost of supply and covering electricity. And finally, we get to this project that we are currently developing at ITC, will be the first biorefinery in the Canary Islands. We have called it BIOGREENFINERY. We are talking about installing 300 kilowatt peak of PV, 100 kilowatt of wind power, and we have a biodiesel genset for backup. We have a small biodiesel plant here at our premises where we are producing biodiesel from used cooking oil. And then we are going to install 2 electrolyzers, a smaller one of 1 kilogram an hour, the bigger almost 3 kilogram, 2.7 kilogram an hour, also nitrogen generator, and a small Haber-Bosch reactor. Okay, and then we have this backup of the biodiesel just to cover the demand of the Haber-Bosch because it's going to be working a very complex conditions of temperature, pressure. So, I mean, to avoid fatigue, thermal fatigue, has to work on a stationary, we cannot force this reactor to be fluctuating too much. So we need to guarantee power supply 24 hours to this reactor, covering with biodiesel for the backup. So the first part of the project, we call it electrolyzer 2, okay, is the big electrolyzer. So the alkaline electrolyzer is only providing hydrogen for transport, okay? We're talking about 150 kilowatt electrolyzer producing 2.7 kilo of hydrogen. We're storing 60 kilogram of 350 bar and then providing the hydrogen to a bus that, I mean, all this tender process, all the procurements have already been done, okay? We have already bought the bus, this small car that will be using the hydrogen. In the case of the bus, it's the Caetano bus that will be supplied. We have our supplier here at the conference room. He will be supplying the bus maybe in 3-4 months from now and has a capacity for 80 people and will be storing about 37.5 kilograms of hydrogen on board for an autonomy of 400 kilometers, and I mean the recharge and the refueling time less than 9 minutes. And then the second vehicle we have also purchased already. It's the Hyundai Nexus, and this we have a collaboration agreement with the Canary Island Health Service. Raul is also here. They will be using, in collaboration with us, this vehicle, and it's a vehicle, again, for an autonomy of 660 kilometers and a capacity of 6 kilo of hydrogen, a consumption of 1 kilogram for every 100 kilometers, okay? And by the way, the bus will be run in collaboration with the island transport company. It's called Global. And then we have the second part of the project. This is the more ambitious and more innovative part. We have this PEM electrolyzer providing 1 kilogram of hydrogen an hour. We'll store it at 25 bar. And in parallel, we have this hydrogen nitrogen generator unit. Initially, we're not going to look at the conventional Linde process. We will be looking at PSA, a pressure swing absorption with a D, to obtain nitrogen from there. Air, 79% of air is nitrogen, so we have just to separate the oxygen. We have this nitrogen, and then we take both. We create this syngas of hydrogen nitrogen. We take it to the Haber-Bosch reactor, working again at high pressures, high temperatures, to obtain 5.2 kilogram an hour of nitrogen that will be stored in a tank for a capacity of production of around 3 weeks production of nitrogen. And this takes us to what to do with hydrogen. Hydrogen is a nice energy carrier, but has some limitations. We have to manage it at very high pressure, so we need to go to do some downstreaming, okay? We go downstreaming to fuels that have hydrogen in connection with another atom, creating molecules that are easier to manipulate, okay? In the case of hydrogen, we have the option of compressing it even to 700 bar and reducing substantially the volume. But again, I mean, if we go to hydrogen, the one that we will be storing at 350 bar, what we see is that even at 350 bar, ammonia will have in terms of volume, okay? 3 times more energy density than hydrogen at 350 bar. That's the reason why we go. I mean, hydrogen even at 700 bars is still gas. Nitrogen at minus 33 degrees is liquid. At temperatures in the Canary Islands, we have to apply 10 bar to have it liquid. What's different, working at 10 bar, that's 700 bar, okay? So that's the main reason. I mean, logistics is what the driver to go to nitrogen. And nitrogen, again, I mean, what we have in industrial process, always Linde, the Linde that will give you the liquid nitrogen, but in our case, the small facility we will be running, we will have nitrogen in gaseosos at high pressure, so that's why we are going to use the PSA system to obtain nitrogen from there. Then with electrolysis that we explain, I mean, just decomposing, and that is syngas of nitrogen and hydrogen going to the Haber-Bosch. Everything, all that electricity demand supplied by renewable energy. So we're talking about green ammonia that will be used as a marine transport fuel, but again, ammonia is also the precursor for other interesting things, like fertilizers, nitrogen fertilizers, urea. You need ammonia. Currently, we obtain that from natural gas, but if we have technology, we can obtain it from renewables, okay? And also, ammonia can be used for other things, explosives, no? Nitrato de ammonia, ammonia nitrate. No? We're not going to go into that business, of course, but I mean, ammonia is a very interesting substance, okay? So we have all these, the 3 processes cover the energy from renewables, and well, what we have is, when you see the stoichiometry of the reaction, what we have is that we come from 4 volumes and we have to end up with 2 volumes. So we need 1 volume of nitrogen, 3 volumes of hydrogen, and come to 2 volumes of ammonia. So to do that, we need high pressures, high temperatures, everything depending on the catalyst that we will be using. I was given a good on Friday that we finally managed to get the provider of the catalyst, and the efficiency, okay? The process has an efficiency of 15%, and but the remaining nitrogen and hydrogen that doesn't react will go into a loop again to the Haber-Bosch, feeding a little of nitrogen and hydrogen to compensate for those that went into the synthesis of the ammonia. And here is the energy balance. We were talking about needing 10 kilowatt hour per kilogram to obtain a fuel that has about 5 kilowatt hour per kilogram of low heating value. Okay, this is in big plants. In our small facility, the consumption to produce that kilogram of ammonia might be a little bit higher. Might be no, will be a little bit higher because we will not have energy recovery systems. And what we will do with ammonia, basically synthesize a fuel that will compete with the current fuel oil used in transport, okay, with a fuel oil that has a low heating value of 11, ammonia with 5, we will need about 17 times more ammonia than fuel, so the tanks of the ships will have to be a little bit, have to be bigger, but then we have the part of emissions, okay, emissions that in the old days of Kyoto, we were talking about 12 euro per ton of CO2, now we are talking about almost 100 euro per ton, okay? This was the highest price CO2 has achieved in 2022, 97.82 euro the ton, okay? Average 80 euro the ton, okay? So we're talking about 100 euro per ton. That means that you have to charge 300 euro for the ton of ammonia, okay? So that is beginning to level the playing field, okay? We're talking about, I mean, and if we, on top of that, have an increase of oil prices, ammonia, green ammonia, will definitely be a cost competitive option for decarbonizing marine transport within the Canary Island archipelago. And we have, sorry, we run out of time. Yeah. No, only last, as part of the installations, we have also installed a gasifier. I told you we have this small plant for producing biodiesel. As a byproduct, we obtain glycerin, okay? We will begin to gasify that glycerin because we're interested in going to power to gas, basically trying through the Sabatier process to obtain synthetic methane, and of course going to more sophisticated things. When we have this carbon and we have green hydrogen, we can go to synthesize other organic compounds, other molecules, and through the Fischer-Tropsch process, try to get to that Fischer-Tropsch wax obtained from renewables, and then by thermal cracking of that wax, obtain different fractions, and the most interesting, of course, of them, synthetic kerosene, to be able to decarbonize air transport using renewables for running the thing. So yeah, final conclusions. I mean, just hydrogen is interesting for us, not only for energy storage, but also in that role of energy carrier for road transports, overcoming restrictions of current lithium-ion battery for transport, and also high pressure constraints in logistics associated with hydrogen 700 bars is forcing to use power to gas, power to liquid. In our case, we have beginning to work with ammonia, looking also for more sophisticated organic compounds later on. And well, it depends on internalizing all external cost in order to have this levelized playing field in order for these new fuels to be competitive. And the Canary Islands, given the excellent wind, solar resources, we believe not only the Canary Islands, all European island regions, by that fact, okay, are excellent natural labs for beginning to develop all these hydrogen economies. Thank you.
Thank you.
And sorry, okay, because I always ask speakers to comply with that. And the other day was just, they gave me 20 and I spent 45 minutes. I don't know how they didn't kick me out of the...
But I think that it's interesting, no, at the end. So I don't know if maybe we can continue with the next presentation or...
Yeah, I think it's best.
Okay, perfect.
I just wanted to say that's the privilege of being the organizer, that you can go over time.
Okay. So, well, the next presentation will be done by Enrique Girón. Enrique Girón is chemical engineer from the University of Complutense de Madrid. He has worked as a project manager in Repsol for 10 years. Now he represents the Spanish Hydrogen Association. He also worked in Ariema. He's going to explain the vision of the Spanish Hydrogen Association about the development of hydrogen economies in European islands. Thank you very much, and the floor is yours.
No, I'm loud. Financing projects such as Green Hysland. I was not involved in that financing, but I was very, very glad to see it happen. So I have a privilege today, which is I have the honor of being the last, but which has advantages and disadvantages. The good thing is that you've already said many of the things that I would have said, which is fine, but I can also react to the things that you have left there in the shadows. And I can also allow myself, since I work for an association which is not looking for money, to be a bit provocative and controversial in my statements. So I hope you allow me that privilege, and with a bit of luck we can foster some discussions and I give you some food for thought. I was asked something very, very difficult to answer, which is how to move or facilitate or accelerate hydrogen economies in European island regions. First of all, I have to say that there is no such thing as hydrogen economies. For me, there is an energy economy, so the problem is energy rather than hydrogen. Hydrogen will be a facilitator for introducing more and more renewables into the system, but it's not an objective per se. The objective is to ensure that we go into a green future, something that is rid of all type of emissions. And hydrogen will help us to get there by facilitating the introduction of renewables. But let me start introducing who I represent. So I hope everybody here, well, some of you might know the Spanish Hydrogen Association. We have been around for 20 years. I know hydrogen was not around almost 20 years ago. It was, no one talked about hydrogen. We have endured a long process of not being heard, not being listened to, and now things are starting since the last 2-3 years to boil up, and everybody is thinking about hydrogen. We endured the long passage through the desert, and we have been trying since then to give voice to the hydrogen sector. And when I say hydrogen sector, it's a strange way of expressing it because there is no such thing as a sector. It's a lot of companies dealing in a very horizontal way with the energy sector, in fact. We have in our membership, which has grown dramatically in the last years, of course, we now represent almost 370 entities, out of which I will show a picture just to try to impress you a bit about it. But we cover all the type of companies, like from oil companies, or what they call themselves now, energy companies, to really end users that are starting to work in hydrogen, bus manufacturers, etc. And since the last 15 years, we have also broadened our scope, and we've tried to represent the Spanish hydrogen sector outside. So we have tried to help the sector move outside. Our mission is always the same, to promote hydrogen and hydrogen technologies. And the way we see it is that, I insist, hydrogen will help introduce renewables and will help the sector become greener. And one of the things that we want to ensure is that this is done by creating welfare here in Spain. So we try to help all the companies, including the small ones, in that. The objective, as I said, is to be the voice of hydrogen, but also to promote and ensure that the R&D projects are done. We have a lot of activities in legislation, or rather than legislation, regulation. We are working, we have a regulatory work plan so that we can try to give voice to what your needs are towards that, those legislation and regulations. We work in ISO, etc. We offer some education, high-level education for students through the different companies linked to the association. And of course, we have a big role in dissemination. We try to show the benefits of hydrogen and also the problems of hydrogen throughout the different landscape. This is just to show off, because we're very proud of our partnership, and we have, as you can see, there's plenty of logos there. If you don't recognize your logo, talk to me later. I will make sure that I trick you into becoming a member. And we have always to thank our promoters because they are the ones that put a bit more money, so we can actually afford doing all this task as well. And as you can see here in the previous slide, we have representative of all the sectors of the economy. Now let's go back to what I was asked. What do we need to have for a fast transition into hydrogen technologies? And I want to be a bit controversial now. So everybody talks about research and development. It is true that right now we have to remember that we are not there yet. The technology is well advanced, and we have some technologies that are already in the market, but that doesn't mean that we don't need to continue improving them. We talk about cost all the time. To reduce cost, we still do need some research on the electrolyzers, but not only the electrolyzers, compressor storage systems, infrastructure development, and also the end users. They need to know we still need to improve the technology a bit. So let's not forget this, because we sometimes, once we have the first demonstration projects ongoing, we think that it's all done. We still need to put a lot of money into research. It still needs to go there. Government action is something that's obvious. We have discussed before, and the fact that this is not yet a market. We are not, I think one of the first presentations was showing the prices that we would have to reach to be able to be competitive with other technologies. We are not there yet. This implies that also we need help from the governments to encourage and enhance this market, to make us break the gap and make this, if not profitable, because it's not going to be profitable for a while, at least we don't lose a lot of money, especially the companies. There is one thing that we have in hydrogen, and we have mentioned it before. Hydrogen is an energy vector, but it's very flexible, and it has a lot of synergies between different sectors. So this is generated especially in industrial power. I know that this is not so relevant to islands, because most of the islands, I'm not saying all, don't have big industry. But if we start generating the hydrogen economy, so-called hydrogen economy, from demand centers, and we can expand for different uses. So we produce hydrogen for one, but not for one end user, but actually for many. And I think Green Hysland is one of the examples of how to start. And here I want to become a bit controversial. There is no market if you don't generate demand. And to generate demand is something that we have to work on with the governments and also with the different industry, because it is demand that will make us succeed. If we don't have demand, and we have to find the demand, it's impossible to go forward. No one will build an electrolyzer and produce a lot of hydrogen if they don't know what to do with it. So that's something that we have to work together. So the demand and the offer has to come together. And for that, we need to work, and we have to foster. One way to foster that demand is by lowering the hydrogen price, of course, and ensuring that the end users don't have to endure with a penalty because they become green, but actually we reduce that. We have seen some initiatives like now the European Hydrogen Bank, which hopefully it will work if they manage to get their mind around on how to arrange that, because they have plenty of money, but they don't know how to spend it. But with a bit of luck, we will get there. Another thing is, it is difficult enough with the technical part. Let's not make it, let's eliminate the barriers, unnecessary barriers related to regulation. So we discussed before, and you were very cautious when you said that it took a few months. I have suffered this permitting process a lot of times, and we have to ensure that this does not become a barrier, that the promoters of projects can move fast, because the projects are not economical But if you take 3 years to make them, to approve them and to put them forward, they become even more hazardous and even more difficult to maintain the interest of the investors. And also, not only for things, of course, safety is a must, but there's some permits that are not being granted as fast because most of the people that have to grant those permits don't understand hydrogen. So we need to do some effort in educating these public authorities or public servants to go there and understand what hydrogen is and the safety measures or the requirements that they imply. And social awareness is something that I have to talk about, of course, especially because of the question that was posed before about the safety. And the Hindenburg, by the way, because the one that you were mentioning was the famous Hindenburg that, thankfully enough, most young people have forgotten, but us that already have some white hair in our faces or our hair still remember what it meant, because it was taught at the university. The Hindenburg was not an explosion, it was a Zeppelin that was loaded with hydrogen, not for propulsion, just for airlift. And when it started burning, because there was a spark and it started burning, it was not the hydrogen that started burning, actually it was the paint covering the whole thing that started burning. Of course, once that burned, there was a leak and the hydrogen burned and got on fire and left, but there was no explosion as such. And without the lift, the thing fell with a... This is something that is in the mind of many people when they talk about hydrogen being not safe. Hydrogen is as safe as any other fuel. You just have to put the safety measures necessary for that specific fuel. And we have to make sure that everybody understands this, because once, when I was working in Repsol, I had a boss that told me, oh, these buses that we were trying the first buses in Europe, 3 of them were in Madrid. He said, no, better that they take this for the Germans, because I don't want my kid to run on that bus. We are the first ones that we have to ensure that people understand that hydrogen is safe. And public awareness is key. You mentioned before that some people are a bit itchy when they tell them that a hydrogen pipe is going to go through their land. We have to explain to these people that there is a benefit for them, that is good for the environment, and the environment is them, and the fact that it is safe, of course, like any other fuel that we use. So beware about public awareness and social awareness, and we have to ensure that we sell this to the public clearly and with clear statements, something that people can buy and understand. One thing that is clear, and in fact with that I could almost stop, because I think that's the big statements that I need to pass forward. But one of the things that we have to make sure is that for hydrogen to be introduced into the islands, you have to understand your island, as we've discussed. I've seen the different analyses that they were done about the Canary Islands. You have to understand what is your hydrogen capacity, how much your energy capacity, how much you can produce, and what are your needs of storage. We are going to move into a energy sector that is going to be zero emissions. Okay, to go there you have to go to renewables, but those renewables, as you were mentioning, you have to be able to decouple them from the demand, and therefore you have to store that energy. And hydrogen is that. The true purpose of hydrogen is to store that energy and to decouple it from the electricity production. Okay, then we have to work on that, and you have to understand what your island is, how much energy capacity, production capacity you have, but also your demand. Where do you need that hydrogen? Do you have industry? Do you have sea transport? By the way, here in an archipelago, you have plenty of ferries moving back and forward. That's a place where you can use the hydrogen. You have to understand what your road transport looks like, the heavy, because we always talk about the ideal of hydrogen being the very, very good for hydrogen heavy transport, road transport, but only if you need the range. It's a question of range also. Do you need it? Do you not? How do you work it? How do you combine this with battery electric mobility and battery electric applications? This is what we have to ensure, and we have to understand before we move into hydrogen. And hydrogen will serve us for many things, and will allow us to reach this independency and energy dependency, because we have to remember that in the islands it's very difficult to import energy if it's not renewable, if it's not here. So that benefit we already have, that the comparison price is already high. But we have to ensure that we do it by benefiting the society. So you have to put in place the proper educational or training in the islands. And this is something that sometimes we forget, because you want to generate employment here, you want to generate welfare. And I think, again, this is the typical, and sorry, I had to put it because it was imposed on me. I think in different ways or means, you all know this slide, because basically it's an energy, and I insist, it's not a hydrogen slide, it's an energy slide. It's all the places where hydrogen can help the energy to move forward. And to understand, each island is a bit different. They have different situations. An island like the islands here, they're, as you mentioned, very balanced in the energy production from renewables along the year. There are others that are completely unbalanced, so they have to understand the storage needs. And then you have to ensure that the end users go along with you. And this is the thing I was talking about, the demand. If the demand is not there, if you don't ensure that you generate the demand for hydrogen in the islands, then hydrogen makes no sense anymore. And it's just for re-electrification, which is also possible, but it's maybe not the optimum. And the good thing is that from what I've been told, because I haven't been able to read it, it is clear that we have the programs and the plans, and we plan ahead and we understand what the future should look like. So we already installed the different means to reach this hydrogen economy, which I insist I don't like the terms. But you have the support from the governments and the different regionals and local governments to accept this hydrogen as for what it is, which is a tool to install and foster the renewable energies, and understand that you need to put some money into it. Another thing that from islands, or very specific to islands, is that most of them are very touristic. And this is something that in Mallorca they have understood. They sell ecotourism as one of their flags, of their selling speeches. Okay, hydrogen can help you to become more eco-friendly. If you go to the travel agencies and you say, no, since you land in the island, everything is green. The transport is green, the hotels are green, everything comes from renewable energy, and you have another selling speech to allow you this extra money that it will cost you to be hydrogen. And of course, and this slide is, it's already been presented in nicer minds, by the way. I'll have to talk to my guys to copy yours. We have to work together. To implement hydrogen is very, very difficult, and we're in the starting point. What we have to ensure is that we learn from each other. I was involved in a previous project to Green Hysland. It was called BIOGREENFINERY. I think some of you were also there. We learned a lot of things there. We made a lot of mistakes there, and we did a lot of good things there. Okay, we have to learn, by the way, big hit or to surf and turf, yeah. They are linked projects. We learn a lot of things, of how things should work and what things don't work. Okay, let's make sure that we communicate and we bring those lessons learned to each other. Especially Irelanders, that you understand each other better. I come from the center of Spain, so I don't have this mentality of the islands, I'm afraid. But I know that from talking to people that you have a special mentality, you understand each other better. Okay, take the examples from these other islands that are trying to move forward in the same direction. And I think with this, because basically this is a summary of the previous, I've provoked you hopefully enough so that we have a nice discussion now. Thank you very much.
Thank you very much, Enrique. The opportunities and the barriers of the hydrogen, no, and mainly the insular electrical system. So I don't know if someone in the room have any questions regarding that. What? Here.
De los 370 miembros que tienes en la organización, ¿cuántos son de las Islas Canarias?
Buenísima pregunta, que me debería haber presentado. So I've been asked out of the 370 members how many, that are in the Hydrogen Association, how many are from the Canary Islands? I'm not sure, to be honest, but I will search for it and I will send you the value. I'm not sure. I don't know, to be honest.
Okay.
Sorry for that.
Thank you.
Anyone from the room? Okay, Melissa, maybe.
Yeah, there was one more question online. It was, let me look again. Yeah, if Spain had already developed a hydrogen roadmap, and if yes, whether we could present it or share it.
Okay. No. I mean, I don't know it in detail, to be honest, but I know that it is published in our website. Basically, I don't think it differs much from the European one, which is basically we have to understand hydrogen needs to start by replacing, so green hydrogen needs to replace grey hydrogen. From there you have to move to other industrial applications, and from there you have to go to transport, and the sequence is like this for the most cases. It is true that this is a general statement. It will differ in different regions depending on where on the energy sources that you have and the conditions that you endure. What it's clear is that for Spain it is seen as it's always been identified the hydrogen as a big opportunity to increase our energy security, but also to become even at some point exporters of energy, and that's where the roadmap is aiming at. Ensure that we install sufficient renewable energy, but also sufficient electrolyzers. We were talking about 4 gigawatts, if I remember correctly, of electrolyzer by 2030, which I think it's very, very challenging, to say the least, especially because, as I said before, and when I was trying to be a bit provocative, if we need the demand to match this amount of electrolyzers, let's not talk about people producing those electrolyzers, because I'm not so sure that we have production capacity for those. But the roadmap looks in that direction. 4 gigawatts, they are talking also about objectives of how much infrastructure, road infrastructure and vehicles to be deployed. I can't remember the number. I think it was something like 150, but I'm not sure whether that was updated.
Okay, perfect. That's an excellent summary. For the rest, they can go on your website.
Okay, thank you very much. I don't know if someone have any question for the rest of the presentations that have been done, because we have to finish with the meeting, the online meeting. So anyone here? And also in online, I don't know if someone.
No, I think it's time to close, but just to highlight the fact that you will all receive the recording and the slides online and on-site participants. So.
Okay. So thank you very much.
So now, thank you. So now what we have is we will stop the streaming, okay, and we will have an open discussion only for the people present here on site at the conference room. Problem is we were thinking on having it. Well, we really didn't think. We assumed that we were going to have it in Spanish. But we have some people, I mean, we have Nicola, for example, he knows some words, no? Mexican Spanish, cerveza, mañana, sombrero, tequila. And we have also our colleagues from Cyprus Energy Agency. They are more proficient, no? They had this
Green Hysland will generate, distribute, and use at least 300 tons of renewable hydrogen locally per year. It will be produced by an electrolyzer which uses solar energy in the island of Mallorca. This green hydrogen will have multiple applications. It will be used in buses and vehicles. It will be used to heat and to use for power purposes in the island of Mallorca. And it's going to be part of the hydrogen is going to be injected in the distribution network in the island of Mallorca.
Es un proyecto palanca, puesto que reúne tanto a la transición energética, a la reindustrialización, a la diversificación y a la modernización de la estructura productiva, siendo estos ejes estratégicos para el futuro económico de las Islas Baleares.
We decided to join this beautiful project because we believe that Chile has a lot to offer to the hydrogen economy and much to learn from this practical experience. We are convinced that the consortium established is a strong group of public and private entities that will successfully accomplish all the goals, and we want to be part of it. So this experience will help us bring important and practical know-how, study the feasibility of carrying out something similar in one of our largest islands, such as Chiloé.
First of all, if you calculate all the people on all the islands in Europe together, then I think it's the 5th or the 6th biggest member state of the Union. So we need to decarbonize also the islands. Secondly, so far, hydrogen has not been really tested on islands. It's pretty new for islands, and we believe that hydrogen has a big potential to decarbonize the islands.
The Green Hysland project will bring to Madeira the opportunity to cooperate with other regions and to follow what is being done on hydrogen technology for energy storage, to increase the capacity to have more renewable energies in the electric system. I see this project also as an opportunity to show the islands as laboratories and also test beds for new technologies.
Las islas debemos ser conscientes de que hemos de tomar la delantera en esta transición energética y aprovechar nuestra realidad insular para llegar cuanto antes a la soberanía energética y a la neutralidad climática, anticipándonos así a los retos que tiene también planteados el resto del continente europeo.
This will be, I'm sure of that, a blueprint for the so-called hydrogen island and an example to promote this type of renewable energy in other parts of Europe.
Gracias, Fernando. Fernando efectivamente fue el que coordinó el proyecto que presentamos, el RES-2H2 en su día, pero vamos, desertó Fernando, ¿no? Se fue a la empresa privada. Gracias, Fernando.